Ma'am will proceed, ma'am. Sir is joining. Ma'am, Daphne,
Yeah,
ma'am.
yeah.
Yes, ma'am. Yes. A very good evening once again. Respected Chief Guest, Dean Ma'am, Associate Dean Ma'am, HODs, distinguished professors, our faculty colleagues, and my dear participants. It's my great pleasure and privilege to welcome you all for our 6-day online FTP on Demystifying Transformers, the brains behind generative AI, which was organized by School of Computer Science, Engineering and Information Systems, VIT Vellore, sponsored by AICT Training and Learning Academy at all. We fixed this title mainly because learning generative AI and transformers today is essential not just for career advancement, but also for staying relevant in a rapidly changing world, driving innovation, addressing ethical challenges, and contributing meaningfully to societal progress. At the outset, I feel deeply honored to welcome our chief guest and the resource person, Dr. Sayan Roy, Professor and Head, School of Computer Science, Taylor's University, Malaysia, who has kindly accepted our invitation to grace this function by his felicitation. Sir, your remarkable contributions in the field of AI and cyber defense have been a true source of inspiration, and we are fortunate to have you share your insights with us this evening. Next, I would like to welcome our keynote speakers who have given their acceptance in spite of their busy schedule from both academia and industry. From industry, Ms. Vaishali, Senior Engineer, Microchip, she will join us in the next session. Mrs. Adi Lakshmi, Senior Data Scientist, Cape Gemini, Chennai, she will join us in the tomorrow's first session. Mr. Jay Ganesh, Lead AI Architect, Value Chennai, and Mr. Deepan Raj, Lead Data Scientist, HCL. Mr. Mohan Raj, Lead Data Scientist, Applied Materials, Karnataka. Mr. Bharat Natarajan, a specialist engineer, PwC, United Kingdom, London. And from academia, Dr. M. Venkatesan, Professor from Department of Computer Science and Engineering, NIT Puducherry, Karaikal. Dr. V. Satish Kumar, Professor in the Department of Electronics Engineering, MIT Campus, Anna University, Chennai. Dr. Tinagra Perumal, Associate Professor, Department of CSE, University Putra, Malaysia. And Dr. P. Kumaran, Professor from Department of Computer Science, NIT Puducherry, Karaikal. Next, I would like to extend my heartfelt welcome to our enthusiastic Dean, Dr. Daphne Lopez. Ma'am, your constant guidance, encouragement, and visionary leadership have been instrumental in driving the academic excellence and fostering innovation within our school. We are truly honored to have you with us today, ma'am, to grace this event with your presence and support. Next, I would like to welcome our Associate Dean Ma'am, Dr. Jeyanthi, whose support and guidance play a vital role in strengthening the research endeavors of our school. A special word of welcome to all the head of the departments, especially Dr. Neelu Khare, HOD SSC. She is the co-convener of this FDP and other HODs who have joined us today. Your commitment and dedication towards shaping the academic framework and mentoring students are truly commendable. Finally, I would like to welcome all our participants and my dear colleagues. On behalf of the organizing team and all the participants, I thank you all for your gracious presence, which adds immense value and encouragement to this gathering. We look forward to your continued support and guidance in making this initiative a resounding success. Now I invite Dr. A. Anita, coordinator of this FTP and professor, Department of Software and Systems Engineering, SCORE, VIT Vellore, to brief us about the objectives and scope of this faculty development program. Over to you, ma'am.
Thank you. Thank you very much, Agilantishwari ma'am, for your welcome address. And I can see here our chief guest, Dr. Sayan Kumar sir, is also joined our session. Welcome, sir. And now I'm very much happy to have an introduction about our introductory talk about our FDP. Good evening, everyone, and a warm welcome to this faculty development program on demonstrating transformers, the brains behind generative AI. In today's fast evolving digital era, artificial intelligence has emerged as a transformative force, reshaping industries, education, and research. At the heart of this revolution lies the transformer architecture, the foundation behind the state of the art generative AI models such as ChatGPT, BERT, and any others. This FTP is designed to provide you a clear understanding of how the transformer works, why they are so powerful, and how they are redefining the landscape of this machine learning techniques. And the concept of transformers may seem highly technical and complex at a first glance, but their core idea is beautifully simple, focusing attention on the most relevant parts of the information. By leveraging this principle of attention mechanism, transformers have surpassed traditional models in natural language processing, image recognition, and even in multimodal applications. So through this FTP program, we aim to bridge the gap between the theory and the practice, ensuring that the participants not only grasp the underlying mechanisms, but also to gain insights into the real world applications and the emerging trends. Over the coming sessions, the experts will walk us through the fundamentals, advancements, and practical use cases of transformer based models. Our objective is not just to decode the technical intricacies, but also to inspire the educators and the researchers to explore how these models can be integrated into teaching, innovation, and problem solving. We hope this FDP will serve as a better platform for collaborative learning and will spark a new ideas that harness the true potential of the generative AI. Thank you very much for being here, the part of this FDP. Over to you, Agila ma'am.
Yes, ma'am. Thank you, Dr. Anita. We have now have with us Dr. N. Jeyanthi, convener of this FTP, to share our opening remarks. Over to you, ma'am.
Yes, ma'am. Thank you, ma'am. Yeah, good evening, all. It's really happy to have 166 attendees in an online session by evening 6:10.
Totally, we have 593 participants, ma'am.
Oh, great. Was such a great outreach, right? It reaches so many people, and we believe that all 500 will be benefited out of these FDP. Really, it will be nice. Yeah. So I hope you are at the right place to learn, start from the scrap AI, and you'll be moving towards. I have seen the contents. It is meticulously drafted. It starts with the concepts, use cases, then it goes to prompt engineering, then multi-agent design pattern, image generation, transformers, LLM, and how the GPTs are working, image classification, and it ends up with a conversational AI and a chat GPT. The content was meticulously drafted, and also the resource persons. I thank the coordinators, Anita, Dr. Anita, and Dr. Agilandeshwari, in identifying the right resource persons who could impart the necessity and the importance of AI into our teaching world, and also thereby we motivate our kids, our students, to come up with not only AI users, let them be LLM developers. I appreciate the efforts of the coordinators, and I thank all the resource persons who have accepted our request and joined for this. I believe this forum will be helping us a lot to shape our content on AI. Thank you, ma'am. Thank you for organizing such an event. Thank you.
Thank you, ma'am. It's my privilege to invite our Dean, ma'am, Dr. Daphne Lopez, convener of this FTP, a professor, higher academic grade, and Dean's Code, VIT Vellore, to deliver the inaugural address. Ma'am, we're eager to hear your inspiring words.
Thank you, Aguila, for the introduction. Good evening, all the participants, and I welcome you on behalf of the school for this FDP. And I think it would be a great one, a great learning for all of you. So we know that AI is the boom, and now that we are moving from AI to AGI, which they mean it to be artificial general intelligence, where the models will think like humans. That's what people say. So we don't know, maybe transformers will also be going away shortly, but these will be the basic models. So transformers are widely used in many applications with both the encoders and decoders being used, and they overcome the challenges in RNN, LSTM, and so on. So it has found a wide variety of applications in healthcare, wherever sequence to sequence is needed. A lot of issues also have come up, and this is based on a paper from Google researchers in 2017. Though the paper was published in 2017, the concept is not new. It is very old. It started in 1990, but people have forgotten about it, and they have reworked on it, and scientists, researchers, all of us have started using transformers as the base model now. So one of the challenges in transformer was, RNN and other LSTM models, though we were able to use sequence to sequence translation, whatever, there was a parallelizing issue. And this parallelizing issue was the major concern in transformers in the basic model of transformer. In the architecture, they again worked on it, and now they have come out with parallel conversion also, sequence to sequence, word embeddings, and all those things. So one of the most, widest applications would be in healthcare, where they try to convert everything. But though it is used in healthcare, it has become very expensive. The computational cost is very large, so that many hospitals in India especially may not be able to use. So is the case with other applications in physics, chemistry, in genomics and other things. But still we are using transformers in drug discovery. In US, most of the clinical researchers are using it, and they have been very successful in it as well. So likewise, we have so many applications, and transformers form the base for all your GPTs, chat GPTs, BERT, and so many models are there. Yeah, we have millions of models that are coming up, and they are now trying to move from transformer to imparting or implementing general intelligence, which will be where the models are, the architectures will think like humans, which is lacking now. See, though we say it is artificial intelligence, it is artificial. So there are cases where these models or the results or the outcome cannot be validated. So how can we go for such validations, and evaluation is the challenge now. So I think when you understand the basics of the transformer or whatever is being covered for you in the next 5 days will help you to understand and learn more about the base architecture, as well as the changes that you can make to the algorithms, learning algorithms, or the architecture itself. So this would be my view on this program. Congratulations to both of them for getting this Atal opportunity. Happy learning to all of you, and good luck. Thank you. Thank you, Akila and Anita.
Thank you, ma'am. Thank you so much.
Thank you so much, ma'am.
Ma'am, actually, Neelu ma'am is trying joining. I think she could not. You please check, ma'am. Anita ma'am, can you able to find her?
I'm checking. Neelu ma'am is
Please.
there.
She joined in some other link she is telling, but I could not see her.
Okay,
Yes,
I will share, madam, the link. No issues.
ma'am, she is telling that the admit permission requires. Is there any permission left?
No. I will make sure that, ma'am, you please proceed.
No, actually, ours role is
Okay.
now. She has to introduce the speaker.
I shared, madam, the link. I will call her.
Okay.
I wish to thank the chief guest of today, Dr. Rai, for your presence and your valuable input, and looking forward for your cooperation with our school.
Thank you so much, ma'am. Yeah, I appreciate it.
Thanks.
Welcome, sir.
Hello, everyone.
Hello, sir.
Akila, you are on mute.
Yes. Yes, ma'am. Thank you. Yes, thank you so much, ma'am, Daphne ma'am, for your motivating words. And it's now my pleasure to invite Neelu ma'am to introduce the chief guest of the day, Dr. Sayan. So I think ma'am could not join. Ma'am, Anita ma'am, can you introduce the speaker?
No, Neelu ma'am joined
I
already.
think Neelu Khare joined.
Neelu ma'am?
Neelu ma'am, you're on mute.
Ma'am, unmute.
Neelu ma'am, please unmute yourself, ma'am.
Yes.
A very good evening to all of you here.
At the very outset, I take this opportunity to extend our special welcome to our esteemed chief guest, Dr. Sayan Kumar Ray, and we are truly honored by your gracious presence today. Dr. Sayan Kumar Ray is the head of the School of Computer Science and full professor at Taylor's University, Malaysia. He completed a PhD degree in computer science from University of Canterbury in New Zealand with full scholarship. While in New Zealand, Sayan worked both in academia and industry in different roles. He has won several awards, including Research Excellence Award, Overall Outstanding Performance Award, and Teaching Excellence Award. Sayan's research is on topics related to cybersecurity, IoT applications, autonomous transportation systems, 5G, 6G networks, and applications of AI and machine learning. His work regularly featured in top-tier journals and conferences till date and has more than 100 publications. Sayan's co-authored papers have won 5 Best Paper Awards and 1 Best Commendation Award in International Conference of Repute. He also has worked for granted 4 grants from UK and Australian patents. So I would like to welcome Dr. Sayan for this FDP, and I'm feeling great to honor you, and I'm feeling honored to welcome you. Thank you so much.
Yes, thank you so much, ma'am. Now we are honored to have with us Dr. Sayan Kumar Ray, Professor, School of Computer Science, Taylor's University, Malaysia, as our chief guest. May I now invite Dr. Ray to felicitate this occasion with his address. Over to you, sir.
Thank you so much. Thank you so much. Really appreciate it. It's an honor for me to be here. And so good evening to all of you in India, and of course, good evening here in Malaysia as well, although it's like almost 9 o'clock here in the evening. So I was just stuck in the traffic, so just managed to get home on time. So again, like it's a pleasure and a deep honor to be invited here for this talk and to be the chief guest of this session. And just looking forward to some of the important and interesting talks. And I just like saw the good line of speakers. Of course, I'm even the first one, but then like there's some interesting talks from the industry as well, which I'll personally like to hear as well. And yeah, I'm so looking forward to the next few days of interesting talks and the sessions. Thank you so much.
Yes. Ma'am, Anita ma'am, I'll now request you to conclude the inaugural function, ma'am.
Okay. Thank you very much, Agla ma'am. I'm very much happy to see that everybody has joined the session on time, and the participants are also eagerly waiting to attend the sessions for our topic of FDP. So we are very much happy to have all our faculty, all our participants, and I'm very much thankful to our Dean ma'am, Daphne ma'am, for giving her insightful information about what we are aiming for. And also I am very much happy to have our associate dean ma'am, she has given us the information and the motivation towards how to take care of this FDP. Also, I'm very much happy with giving a welcome note of our chief guest through our HOD Neelu Khare ma'am. It was very much helpful for us, ma'am. And thank you for all your blessings and giving us this opportunity to carry forward. Thank you all.
Now I request our Dean ma'am and Associate Dean ma'am to declare the FDP open.
I declare open the FDP.
Thank you, ma'am.
Yeah, I second it. All the best.
Thanks, ma'am. Thank you so much for your presence, ma'am.
You can start, sir.
Okay. Yeah.
If possible, can you share your? Can you turn on your camera, sir? If possible.
Is it off? Is it? Oh, sorry.
Yes, sir. We can see you.
Yes.
Thank you.
Yes, sir. Thank you, sir.
Thank you, sir.
Yes.
Okay, so good evening, everyone. And again, it's a pleasure to be here in this talk. So before I start with my talk, which is titled as AI Advancements and its Role in Cyber Defense, Just to give a little bit of brief about our university. So Taylor's University in Malaysia, located in Kuala Lumpur, around like 30 minutes of drive from the city center of Kuala Lumpur, in a place called Subang Jaya. So this is a private university, but like currently ranked as the #1 private university in Southeast Asia, and so that's for the QS ranking. And we got around like 23,000 students roughly in our campus, so part-time and full-time, and we have got 16 different schools under 4 different faculties. So at Taylor's University, we also have a Taylor's College in the same campus running. And our School of Computer Science is currently the biggest school in the university, and it's grown quite fast in the last few years. We are currently ranked within the top 100 in Asia in data science and AI, and within the top 250 in computer science and information systems, although we do not offer information systems in our school. So so we always look for like collaborations, and so we welcome like any interest of collaborations in research or anything else. Okay, please feel free to ping me and just share me an email, and of course I'll get back to you on that. Okay, thank you. So the talk today, from AI advancements and role in cyber defense, as you can notice, it's got 2 different parts currently. So since this is the first talk of this program, so I tried to put in some basics of AI, okay, just to get the ball rolling for the other speakers as well. And then, of course, in the later part of the talk, I'll slowly move to the cyber defense side. So I have tried to make things quite basic so that like I don't really go in depth, just thinking of the audience here. And so in the talks, I'll be kind of like sharing a couple of demos as well, which are kind of like snippets of the consultancy projects that we do with some of the SMEs in Kuala Lumpur. So of course, like I cannot really show the whole thing, but just some snippets that I can present as part of the demo, or some kind of like what we do in terms of AI-enabled cyber defense. Okay, so let's start. And as I said, so I've tried to keep things quite basic, and the first part, of course, like many of you will already be knowing what I'm trying to say here. So this is a brief contents of the talk. So I'll talk about AI in general, and I'll talk about AI types of AI, including generative AI, ML, AI agents, and we'll touch upon the agentic AI side as well. And I'll talk a little bit more of the generative AI, since this FDP is on the generative AI side as well. I'll slowly give an AI agent demo, again a very small one from one of our consultancy projects that's happening. And then I'll move to Gen AI with cyber attacks and cyber defense, and some of the research topics of interest, and again, like another example. Okay, so of course, like AI is now everywhere, and anywhere we go, anything we read, it's all about AI. And there are a lot of companies here in Kuala Lumpur which are actually working on the startup space. And they actually come to us and for consultancies and for collaborations. So basically, all those different fields that I've shown in this diagram, plus more, we are, along with the School of Engineering and School of Bioscience, Health Science, we are doing something on the AI here. And these are the different areas or the different types of AI things that can be done. AI can be in retail, in home furnishing, logistics, financial industry, manufacturing industry, electronics, healthcare, anywhere. So nowadays, you name anything, there will be some kind of AI application that people are working on. So now this is a slide which is almost like now 2 years old, and I still maintain this slide when I give talks. So how intelligent is AI? Now, a lot of things have changed, and a lot of things have evolved, but like whenever I go to the different events, including like industry events, and or whenever I talk to the different clients who are not that pro with AI or with digitalization or with computer science as a whole, I hear the saying, okay, so can you please do this for me? And if I say this could be a bit difficult to do, and say, oh, why can't we use AI to do that? So many of the people have got no clue actually what AI is. Okay, they are just like going with the flow with the buzzwords. So I try to kind of maintain this particular slide, okay, just to give an idea of what AI can and cannot do at the moment, and exactly what AI is about. So of course, like what I tend to ask people is like, how intelligent is AI? Or rather, like people actually ask me at times. So these are some of the questions that I actually framed here based on what I hear from the people. So do AI systems understand between what is right and what is wrong? Or can they question why is something happening, or how has something happened? Or can they understand the consequences of any actions or decisions taken by the system? And then are they really guided by any values? If yes, then what are the values and whose values are there? Are AI systems really responsible or trustworthy systems? So whenever I try to explain things to our clients, many of whom, as I said, are not from the AI background, but they have just heard some buzzwords, AI, machine learning, and they think that anything can be done with AI. And of course, there's a lot of things like AI taking the job. So whenever I go to some forums, these are the discussions happening there as well. So AI is nothing but a black box. You just like input something, uh, and then like you get some output based on certain algorithms or the decision making. Now, the output that we get based on the inputs are basically the internal behavior, of the code that we write. So basically, the human being who produces these AI systems, and the human beings, they are the one responsible for these systems. So basically, what we code and what we kind of design, we get an output like that, as simple as that. So AI as a whole is nothing but a black box. Okay, we try to make it intelligent. So coming to those points, then if we move on, then what are the different types of AI? So of course, AI types on capabilities. We can call them narrow AI, general AI, and super AI. These are mostly the three broad types. And based on functionalities, the reactive machines, limit memory, theory of mind, and self-aware AI, which kind of like there's on the capabilities as well. So narrow AI or the weak AI is something that we can see now, and it's happening now, and they're trained for a specific task or a narrow range of tasks, and they cannot perform anything outside the trained tasks. So that's how it all started, okay? And then like slowly it gained some intelligence, and now we can see based on the functionalities, things like reactive machines AI, which are under narrow AI, and these systems have got no memory and they're designed to perform specific tasks, but they cannot recollect previous outcomes or decisions. So these are the early days, so like Deep Blue or like AlphaGo from Google's, and we have like Siri and Alexa as well. And then like we move to what we call the limited memory AI, where the AI can actually recall past events and outcomes, but can store them over a limited time, and they can actually create new outcomes based on what's been input as well. So that's where the generative AI things come. And of course, we see a lot of intelligence being embedded in Siri, Alexa, autonomous cars. On the other side, if we talk about the general AI or the strong AI, they are the artificial general intelligence, okay, which aims to perform any intellectual tasks just like human, like efficiency. So that's the main end goal of these kind of systems. So they are typically hypothetical, and there are a lot of research going on that side, but nothing concrete has been developed so far. But of course, like we come to hear a lot about something called emotion AI. Okay, so on that side. So here the AI can understand of the thoughts and emotions, and that's what the scientists are looking for. So can they really simulate human-like relationships and emotions as well? And then of course the last one is the super AI, where it's kind of like that's what we see in any of the sci-fi movies, like so AI performing just like humans or kind of like exceeding humans' intelligence as well. And again, like if ever developed, it can actually understand all the internal conditions and human emotions and thoughts, and then you can mimic it, or rather, like, I mean, so some people are saying that they can actually exceed it. So again, like this will be an advanced level of emotion AI. Okay, so technological fields of AI, as I said, so anything, any of the fields can have like AI systems on that, and so there's a lot of advancements going on. On the algorithm side of AI, on the hardware side of AI, or chip making, computer visions, NLP, so AI-based integrated applications on the different fields like SCSI networks and so forth. AI-driven development on the cloud services, PaaS, Edge AI. So there's a lot of things going on. So in our School of Engineering, faculty, of course, so we are working with the engineering school to develop some smart robots. So along with a couple of industries, one from China and one from Kuala Lumpur. So of course, we are trying to develop next level of robots which can actually predict what human might want. Okay. So for example, so currently we have got a humanoid robot and few humanoid robot dogs, and they can actually perform based on the commands given to them. They can understand. But what we're trying to do that, let's say for example, if the dog is climbing the stairs, and it know after climbing the stairs, it might go to a certain room, and that's what the route it follows. So now of course we have to give a command. But what our researchers are saying, okay, can it really now learn the route and then take that route as well? So a simple example I'm giving. So this kind of things are happening in our faculty. So moving on to machine learning, deep learning, Gen AI, and LLMs. So this diagram shows, so AI is a broad field, and then we have got machine learning, and deep learning is kind of machine learning in a way, and then Gen AI, which actually works based on the deep learnings aspects as well. So Gen AI, of course, refers to technologies that can create new and unique outputs like images, videos, music, text from any of the learned data. And it relies on advanced MLs like GANs or variational autoencoders. And so it takes large data sets as input, and it can produce, and it can actually kind of learn these data sets, study these data sets, and produce new contents in multiple different forms based on the identifying patterns in existing data. And of course, it uses LLMs, and of course, this is one of the autoregressive models that Gen AI uses, and through that it produces human-like text. So based on ML frameworks called transformers. Anyway, so again, these things are quite well known to everyone. I won't really go too in depth. And some of the examples, of course, are OpenAI's GPT, Google Gemini, and there's a lot of these things coming in the market slowly. So again, a bit of background about what is the difference between discriminative AI or the non-generative side of the AI and the generative AI models. So of course, discriminative AI, as can be seen in the picture, it uses supervised learning, machine learning algorithms, and can recognize patterns in data sets and can make predictions and classifications, new samples, but it cannot generate anything new. On the other hand, generative AI models, it mostly uses unsupervised, at times can use some kind of a semi-supervised as well, but it can generate new or non-identical samples from underlying patterns in data sets. It doesn't need to have any of the pre-labeled data to learn from, okay? And it can use unstructured data sets. So that's a primary difference between the two. And Gen AI uses various techniques and can be seen in this autoencoder picture. So it can include neural networks and deep learning algorithms, and it can identify patterns and generate new outcomes based on them. So that's a major difference between the discriminative AI and the Gen AI models. And of course, types of Gen AI and the Gen AI models. So we have got GAN, or the Generative Adversarial Networks. It can produce multimedia and artifacts from input text and images. I'm not really going to in depth of any of this because this is actually quite well known by now. And then the example is that we've got a style GAN, which can generate human-like faces. Then you have got autoregressive models, or the LLMs as an example. It can generate step-by-step output sequentially, pixel CNN, and few other examples on that. Then you have got variational autoencoders and encodes and decodes data distribution, DeepMinds, so VAE is one of the examples for that. And then you have got recurrent neural networks, reinforcement learning, and transformer-based models. So these are the primary models for the Gen AIs kind of thing. So the reinforcement learning is quite important. in this, the models actually learn by the reward-driven generations. And for example, if you use the ChatGPT and then like fine-tune with the human feedback, okay, based on the reinforcement learning, so of course it will become more useful, okay, and that's what is now happening slowly on the ChatGPT side. And so AI can be used in the text generation. So ChatGPT, Gemini, Jasper, these are the most important ones. Image generation like DALL-E, which can actually generate so picture from the text. Audio generation, so I'm sorry, shall I continue?
Yes, sir, please.
Sorry. So audio generation, which can kind of like synthesizes music or human speech. For example, Music LM, which composes AI-generated music. Example like Jukebox. Video generation as well. Example Sora, which can generate video from description or from any description that you can actually input. Or there's another one called Pika. If you have tried Sora, it's actually quite interesting. And of course, like Sora will be soon embedded on ChatGPT as well. They're already giving a beta version, I guess. And then for the code generation, of course, GitHub Copilot. I think the majority of the people who are working in AI and machine learning and GenAI, they have already used a Copilot. And there's also something called a code whisperer, which you can try. In case of like 3D or the design generation of the 3D model, you can have like Kadeen, which is slowly becoming quite common, and it can turn any of the 2D pictures into 3D. And then you have got NVIDIA's Gate 3D as well. So these are just some of the names I've given, and there are heaps of different tools and technologies now coming to the market. It's almost like mushrooming every day. So moving on to the future era of generative AI. So where we see AI in the next 5 to 10 years. So there's a lot of different trends that have been predicted, like what will happen to Gen AI. So I've just like put in some of these here from one of the papers of Siemens, and then of course like attended one of the workshops conducted by Siemens as well last year. And there's some very cool, interesting topics they brought, like what they are doing and what the future era of generative AI are. So they highlighted like these 5 different areas as a key predicted trends of Gen AI. Industrial foundation models. So these are kind of like large-scale AI models for industrial work, and these models can be trained on specialized industrial sector data. So it's kind of like they are trying to sectorize the LLMs. So instead of LLMs being general, they are trying to kind of like sectorize LLMs and Gen AI. That's what they're predicting in a way. And one of the big things that they are forcing is the industrial foundation models on that. And these kind of models can be applied anywhere, and as long as it's like a large industry kind of things, industry settings. Here, of course, one of the use cases I put is like energy foundation model that can optimize the global grid operations and turbine maintenance. So specifically, what they foresee is that like there will be LLMs based on the different sectors or even like applications oriented, not like a generic anything. And they're like generative AI models, which will actually focus on like personalized or like sectorized applications as well. Age models, of course, like this kind of generative AI models are quite heavy nowadays, but how about like if you can make them quite light and they can run on your edge devices, okay? So that's what the age models will look like in future. And so optimized AI models that can be deployed directly on constrained local edge devices, and who knows, maybe on your smartphones in the near future as well. So that's what like Siemens see as a trend, and there's actually research happening on this side as well. Quite a lot of research happening on this side. Use case are the AR or the augmented reality safety helmets, okay, that can provide real-time hazard detection and guidance on site. So this can be like a typical and use case for that, which can be kind of like used by the first responders or anyone who actually works on a hazardous situation. These helmets will be quite handy. Okay, then moving on to agentic AI. Again, like agentic AI is like autonomous AI systems where multiple AI agents or AI softwares like work together that can plan, act, and collaborate with humans, but of course moving ahead completely autonomous. Okay, without any human interaction as well. So agentic AI will slowly get traction. Already we can see some agentic AI systems happening and coming in the market, but this will actually grow in future. And use case is like anything can be under an agentic AI as long as there is AI and as long as multiple AI agents or AI software are kind of working there, collaborating with each other. So here, of course, one of the use cases I put is like procurement agents to purchase goods, and that can autonomously negotiate something, and then order something, process the transactions globally, even the payment and everything. Multimodal LLMs will be very important. So models processing and reasoning over text, images, audio, video, sensory data, anything. So it can actually take any different types of input, collect them, and can get with output. Okay, so that's what the multimodal LLMs look like. So use case, let's say like a maintenance assistance, a multimodal AI assistance used for repair work that can integrate the different manuals. Okay, it can auto read the different manuals. It can take into the different video feeds. Okay, related to that maintenance work. It can have the different IoT feeds on the sensors, telemetry, take everything together, collect them, and then do the repair work or the maintenance work for the repair as well. So this will be very important moving ahead in the future. Specialized hardware, now for all these things to work perfectly, less delays, efficiency, etc. Of course, like we need like specialized customized hardware or AI chips for that. And these custom accelerators will be designed to maximize, AI training and interference performance. So use case is like photonic AI chips, which can enable, week-long model training to just like within several hours. Of course, these kind of trainings, which now takes a lot of time, even like weeks, can be much faster as well. So these are like some of the predicted trends that might happen in future, predicted by Siemens. And there are other trends as well. So these are some of the key things that I've just mentioned here. So before I move on to AI agents, just to give you an idea. So I thought of like, okay, this could be an interesting thing to see how we have evolved, okay, on the AI side. So if we go back on the 1980s and then like early 2000, we have the rule-based automation, where early AI system that can prefine the rules to automate repetitive tasks. So basically, you just put some input, and there's a rule engine, and you get output, so automated response. So these are the very basic early like rule-based automations that we had, and then we have got machine learning coming out slowly and been used heavily from 2010, that particular decade onwards, and that can do anything between data collection, then training the model, pattern recognition, predictive analytics. That's what mostly machine learning is used for. And then, of course, like after that, we have the LLMs and Gen AI, okay, where the data collections are done through to large language models, which are trained on the base data set from the websites, books, code, and things like that. So it kind of gets trained, and there's a model architecture. The transformer models process text to multiple attention. Here, of course, we are using text because that was the early thing. But nowadays, of course, you can have other things like voice, sensor data, and so on. And of course, there's a pattern and relationships and context which are learned through this training. And of course, then you get the output. So that's how the Gen AI actually works. So it creates new output based on what the sample's given. And moving ahead, we're slowly into the era of now autonomous AI, where AI agents, which has become a very interesting topic almost in the last 1 to 2 years. And there's a lot of industries which are working on that, and a lot of research which is already happening. and then the agentic AI, which kind of like collaborates multiple different AI agents and to complete a full process end to end. So that's what we will see happening now and what we'll see in future more. So on the timeline for the development of the future AI systems I've got here. So 2025, 2030, roughly, we can see like more of AI agents and agentic AI. Some advancements on the emotional AI side, and of course, like we already have the quantum AI concepts, being researched and been talked in the different conferences. So there'll be some limited quantum AI thing happening as well. Next decade, 2030, 2040.
Sir, you please proceed, sir.
Thank you.
Sir, you are muted, sir. Kindly unmute.
I don't know when it's got muted.
Yes. Now you are audible, sir.
Thank you. Okay, so let's to start again. So timeline for the development of future AI systems. So of course, we talked about 2025, 2030, the AI agents, agentic AI, some happening, some advancement on the emotional AI side and limited quantum AI. Then the next decade, right, we could see more of like collective AI and biological AI. Of course, on the biological AI side, there are some advancements happening on the medical, on the bioscience and those kind of things, which will see more of a clusterized LLMs, okay, on that particular sector and then like clusters as well. So, and then of course expansion of like quantum AI as well into the new industries. Although only today morning I read a report on the quantum AI. So the happenings are like quite slow, so people are thinking like whether with the quantum AI, how far will they go or how fast will they grow actually in a way. And then 2040 and beyond will be kind of an era of the AGI or artificial general intelligence. So AGI with human-like intelligence, like some advancements on there. And of course, it's a merger of AGI, quantum AI, biological, collective, and so on. So of course, what is the thought process behind AGI? It's mostly, as I said, it's mostly a theoretical or hypothetical concepts as of yet. And that kind of like wants to have human level cognitive abilities and enabling AI systems to kind of like think, learn, adapt like human, and can do different intellectual tasks like human. But of course, like unlike human AI systems, the advantage will be these systems, won't get tired or feel fatigue. At the same time, there will be a lot of challenges as well, because as I said, so how responsible will be AI systems? So a lot of responsibility lies on the people who will be kind of like designing and developing, this kind of AGIs in a way. So, and of course, like I've got an example here is how very simple AGI system might look like. So imagine you've got a self-driving car, and it can it's like autonomous self-driving car. It can not only pick up passengers, from the location, and can navigate the unfamiliar roads, but it can also adapt to the different conversations it can have with the passengers in real time in their local language as well. It can answer personalized questions to the passengers, like whatever the passengers might ask. And on, for example, the local culture, on the local cuisine, or the local geography and so on. It can even suggest like local eateries and so on. So this is just a very simple example I put here, like what a simple AGI AI system in form of an autonomous car might look like in future. So again, moving on. So currently we have got AI systems, Gen AIs, which are quite static in their behavior, but we are slowly having these AI agents which are a software entity that can perceive environment, process the input, and then takes action to produce outputs. So these are the agents which actually work or operate autonomously. It can adapt to new information, and of course, with multiple iterations, its behavior can improve over time. So it can perceive, decide, and act on certain tasks autonomously. So this is basically what the agents are. And then, of course, in future, we'll have agentic AI, where the whole system, end-to-end can act autonomously without very nominal human intervention or practically no human intervention. So AI agents basically accomplishes the specific business goals by making decisions and, of course, like takes action based on data, objectives, and feedback. And they can do, language processing. They can have like decision logic embedded, and they can also integrate with certain tools and technologies to perform the tasks they are given. Okay, so basically, what AI agents will be doing, it will try to kind of understand what it has to do. It will try to adapt to the system. It will try to learn from the input data and the pattern. And then, of course, it will try to provide output to a certain task being given without minimal human intervention. That's what AI agents, which are software entities, they'll be doing. So the key features, of course, autonomy. It can operate independently without predefined boundaries. It will have a goal-driven behavior. So, of course, it can execute multiple steps to kind of like fulfill the requirements or get the outputs. And it can automatically integrate, understand the tools and technologies and the APIs needed, and it can automatically call those APIs and integrate in the system. And then adaptability, of course, learn from outcomes and then refine their behavior over time. So the behavior can be improved over time if there's some repetitive tasks happening. So this is just a list of some of the AI agents. There, I mean, like every day I can see some new AI agents being added, but this is just a non-exhaustive list that I've just compiled here. So of course, like under the different categories, like reflex-based agents, where agents can act immediately using rules or models without long-term reasonings, based on mostly on the reflexes actually. So, and then of course, like goal-based agents, where it can make some decisions leading to a goal, and of course, like possible outcomes. So, so the different types of AI agent under reflex-based agent could be simplest reflex agent. And example of a real-world case study is like self-driving cars acting to, reacting to obstacles. Of course, like whenever you are riding a Tesla, let's say, for example, and if you can see some kind of obstacle, it will react. Okay, it might stop, it might slow down, it might just indicate whatever. So this is the Tesla autopilot lane keeping. Okay, as an example here. Then, for like model-based reflex agent, uses internal model to track unseen part of environment. Smart home thermostat that can adjust to the temperature. Okay, right. One of the real world case study. Reactive agent is a video game NPC enemy. I haven't really tried this, so I don't have much idea about that particular video game. So it responds instantly to the stimuli, so no planning or memory. So. And goal-based agents, so basically what it does, it can select actions that help to achieve a specific goal, like a robot planning a delivery route. Okay, so of course, so as I said, so we are trying this now with in our School of Engineering with computer science. We are seeing if our robot dogs can easily find the delivery or the routes to navigate to a certain location, like. And then utility-based agents, so like stock trading decision making is one of the real-world case study. Quant Connect is a simple tool that helps with that. And deliberate agent, which uses reasoning and models to plan long terms. Space mission planning, so NASA's autonomous rover is the example of that. And then you've got hybrid agents, which can combine reactive responses with deliberate long-term planning. Industrial robot automation is one of the examples of a real-world use case for that. And then we have got learning-based agents that can adapt and can improve by learning from its data or previous experience. I mean, so for example, you can have the personalized recommendations, okay, by let's say some of the so of course let's say nowadays if you use the latest version of Siri or Alexa, it can give you some personal recommendations. Okay, more than what it used to be. So and then of course we have got example here, the Netflix recommendation system. So the recommendation systems, they are now getting very intelligent, and of course learning agents are the agents that can be used there. Then of course you come to the specialized or applied agents, which are agents with for domain specific tasks, or for the human and AI interaction. You can have conversational agents like ChatGPT, of course, and then Google Dialogflow. You can have recommendation agents, for example, one of the so real world case study could be e-commerce product suggestion, Amazon recommendation system. Then you can have other different agents like collaborative agent, monitoring agent, mobile agent, autonomous agent. So this list is actually increasing. And there are a lot of agents that are being added to the list. So coming to agentic AI, so how it actually works. So all these agents, if I actually go back to this picture here, sorry. So this fourth picture here, that shows the agentic AI. You've got like multiple agents which collaboratively operate with each other, and that makes the whole autonomous AI system, okay, where end-to-end things can be done autonomously by the different agents collaboratively. So that's roughly what is agentic AI. And of course, there are some other things as well. And so agentic AI refers to AI systems that don't just generate outputs like what Gen AI does, but act autonomously in pursuit of goals. So basically, it completes the process end to end. So it can decide on its own, okay, to reach a goal. It can take actions on its own to execute certain things based on certain tools, apps, or real-world system that integrates to to reach that goal. It can learn and adapt from the results, and it can coordinate with other agents or human beings. So roughly, that's what the whole agentic AI framework is. So these are our agent. So AI agents, basically what it does is can have medium autonomy and limited memory. And AI agents typically execute short and discrete tasks. Okay, but agentic AI, it kind of like collaborates the different AI agents together and can manage the complex workflows end to end using shared memory and inter-agent communication, and with or without human oversight. So this is like a layered collaborative intelligence. So if we talk about how a system with agentic AI, AI agents, and generative AI works, so roughly Gen AI creates certain thing, for example, new output. Agentic AI acts on those, use those outputs to do certain things. I'm sorry, AI agents acts on those, and agentic AI integrates all of this together to operate independently in a complex environment to complete a full process. An example, agentic AI-based automated research assisting system. Let's, for example, here, if you want to do multiple things, for example, you want a system that can kind of like search your academic papers, and then summarizes the findings based on certain input, and then like you want to write a grant proposal aligning with this finding with the requirements of the grants, and then want to draft a full-fledged proposal, okay, with all the findings. If you want to automate this whole system, because of course, like all of us academics know how much time we have to spend, to write any of the grant proposals, okay. So it'll be really interesting if a system like this can automate the whole thing. So you can have multiple agents working together. For example, one agent can actually search the academic papers, and then another agent can summarize the findings from that, those search of the papers. A third agent can align the proposals with the grant requirements based on the findings, and the fourth one can actually draft the whole thing, okay, with all these findings. So these agents will be working together under a certain controller, which actually controls this in all this agent and the whole workflow. and they learn from the previous iterations and adapt the outputs based on the evolving goals. So this is a typical example of an agentic AI-based automated research assisting system, for example. So, so we have got some more examples here. So AutoGPT, which will, so we can see a little bit of that in the next version coming up. So autonomous system built on top of LLMs, and then of course, like you can kind of like do a lot of things using those kind of like AutoGPT things. And then like customer support automation, where the whole system can be end-to-end automated, so not just answering queries, but like filing up, support tickets, okay, to get something done, checking the databases, escalating, a process or a complaint whenever needed. Then you can also have like supply chain optimization agents, which can dynamically adjust logistics, order the stocks, and schedule delivery routes based on live data. So in short, generative AI, it creates content based on text, code, image, plans, and so on. It provides reasoning, creativity, and structured outputs. And then, of course, LLM writes the Python code for automation. AI agents, they work on these LLMs, execute tasks based on the goals and rules, use generative AI to decide actions and then perform them. And of course, these agents run the Python script, which are generated to do those actions by generative AI. Agentic AI is a whole end-to-end system that automatically manages the goal and actions. It combines both. So of course, the goals, the generated output, executes, and then adapt to the system. So AutoGPT can plan research project, it can write it, test, iterates. So just an example here. So let's say if we talk about the workflow of an AI-powered travel planner, okay, which will have agentic AI, generative AI, AI agents working together. So how will the workflow look like? Okay, let's say, so Gen AI will be creating a draft travel plan based on the preferences of a customer. AI agents will actually book the flights, reserve the hotels, check the visa requirements. Agentic AI will manage the whole trip, planning end to end. Okay, it can adjust the bookings if needed, adjustment of the delays of the flights or cancellations of the whole booking needed. So everything will be handled by the agentic AI kind of autonomously as well. So understanding the input is done by generative AI. For example, if a user or a customer wants to send a chat email or query, Gen AI interprets the request and converts it into a structured prompt or context. Okay, and then it delegates to the agentic AI layer, which kind of like orchestrates the whole agentic end-to-end process flow, and it decides which specialized agent should handle that particular task based on the customer query. And then for the execution will be done by the AI agents. Okay, so the chosen agent will execute the action. It will call the APIs or the databases, will do it, and hand it back to the agentic layer. So that's how the whole thing works. So I'll come to this diagram, but let's say this is the example I just talked. So let's say the customer asks, I need to rebook my flight for tomorrow. Okay, and then the Gen AI will understand the intent of the customer. That means it's a rebooking request. It will then like pass it on to the agentic AI layer, which will see, okay, what it needs, and it will understand, okay, it's a rebooking agent to do the task. So it chooses the rebooking agent. The rebooking agent then queries the flight schedule API, okay, about that particular rebooking request. I need to rebook my flight for tomorrow, and the results which come back is a generative AI summarized and then replied back to the rebooking, to the agentic AI. So your flight has been successfully rebooked for 10 a.m. tomorrow. So that's how the whole process flows. So customer asks on the, on the front end form, okay, I need to, or like a request, I need to rebook, and it goes to the generative AI, which understands the intent. Yes, it's a rebooking request, passes it on to the agentic layer, which then chooses the rebooking agent because it's a rebooking thing to be done. The agent then like queries the flight schedule API, which then connects to an external database, okay, and then gets the replies back, and then it's like summarizes the reply. Okay, so if I go to here, if I go to this particular diagram workflow, that's how the whole thing as a workflow may look like. So agentic AI is the orchestrator, and it plans the whole thing. It it kind of like shares the memory, and it takes the agent, verify the results, ask for any kind of improvement, all done autonomously. And generative AI, in this case, you've got the conversational LLMs that like talks to the customer, the summarizer, which kind of like summarizes the output, and the policy reason, which is to take care of any of the booking, rebooking policies and things like that. And then, of course, the AI agents running on these is the booking system AI agent, refunding system AI agent, rebooking system AI agent, notification AI agent, and of course the CRM of the case. And these agents, as and when needed, connects to the different tools and APIs. Okay, could be the database, API flight schedule, the payment refund API, and so on. So that's how the whole thing works, let's say. So the benefits when these kind of agentic AI systems are being developed, of course, human-like interaction with precise back-end execution, because this whole thing is actually happening on the back end. In the front end, for the form and things like that, but AI agents and agentic AI, the mostly works on the back end. And the scalable automations across the industries, banking, travel, healthcare. So of course things are automated, which kind of like reduces time and increases efficiency as well. Continuous learning, as agentic AI, of course, learns from the iterations, and of course improves the workflows all itself. So this is a small demo, which I'll quickly play. Okay, this is like what we did is that like we are working on a small consultancy project with an SME company in Kuala Lumpur, and this is a sales data from that company on the different sales of automobiles. We are trying to search this whole sales database, which is not currently an LLM, but it's like quite big in a way, but we cannot totally call it an LLM still. So we are trying to see based on the request of the customers, can we search for the different automobiles? Okay, it can cars, it can be motorbikes, and so on. So this is what we did, and so I've asked my colleague who's actually working on the project with me just to create this demo and then just like explain this so that I can play here. Please let me know if you cannot hear the voice. Okay. Oh, sorry.
So you can proceed, sir.
I'm sorry, can you not hear it?
Sir, you can proceed, sir. It's audible.
No, sir, it's not audible.
It's not audible, is it? Oh, I'm sorry.
Yes,
I'm sorry. Okay,
video
okay,
is not audible.
Oh, I'm sorry. Okay. So of course, Susan, I'll just proceed. Sorry for that. It's actually audible here, so might be, yeah. Okay, so this is basically a demo that we have created, a small agent and so on. So I'll just like skip it. Okay. Right. Okay. So moving on to now the cyber defense side. So a lot of things happening on the cyber attacks and the cyber defense with the generative AI, and now with AI agents, coming into play. So type of threats and attacks that used to happen worldwide, that the nature of these attacks are slowly changing, and these attacks are becoming more and more intelligent with the advent of the generative AI. So, so the market side for AI in cybersecurity, 3 years back stood at like 7.58 billion, expected to be 8.83 billion by 2030. And these are the different types of AI-powered cyber attacks that we can see slowly happening. So a lot of like cyber attacks was happening, which was not AI-powered, but nowadays, of course, with the AI things, these attacks are becoming more deadly. Okay, so on the exploitation side, data theft, phishing, smart botnets, evasive malware, DDoS, and then vulnerability discovery. So you take any of the cyber attacks, you add a little bit of like AI algorithms to that, and nowadays with Gen AI, it will kind of like become more deadly with the nature of the attacks changed almost. So Gen AI, of course, it can create new data or content based on existing data or content. That's what I said. So for a cyber security, it can act both as a boon or as a pain. That means like it can create more deadly attacks, and it can also help to create cyber defense for those deadly attacks. So the dark side of Gen AI, of course, it can pose significant risks, including the potential for more sophisticated cyber attacks, advanced social engineering, and creation of evasive malwares, for example. And these attacks are designed to bypass traditional security measures and posing a significant risk to the digital systems and networks. So these kind of like cyber attack mechanisms or cyber attack systems can kind of like replicate and create content which are almost identical as human content. Now, this is what it makes so deadly, that it can actually replicate content and create almost human-like content. So very difficult to identify which is created by AI and which is genuine. So it can work both on the phishing, malware, deepfakes, and identity theft. So sorry, can you hear me? Hello, can you hear me?
Yeah, we can hear you, sir.
Okay, sorry for that. I just like had a message here on my side. So let's say for phishing, okay, phishing can become very deadly, okay, with the Gen AI content of phishing. It can be very difficult to even understand which is a phishing, which is developed and generated manually, or a phishing which is like Gen AI, adopted. Same with the malware, okay? Malware is kind of a nature of the malware are like slowly changing every day with the Gen AI algorithms there. Deepfakes, all of us know how deadly deepfakes can be. Identity theft. So Gen AI can create forged documents, for example, your personal stolen details from your banking sector. Okay, that can look like real ones. It will be very difficult to identify which one is a fake and which one is real. So
Participants, kindly mute yourself.
Thank you. So I've got here some examples. Let's say this is from a Google email, okay, a Gmail, which is kind of by AI. It's almost look alike, okay. So phishing emails which were not created by AI, there were like certain things, for example, in the URL or the email ID, you can identify, okay, that's a phishing email, okay, if you are into cybersecurity. But with AI and Gen AI crafted phishing email, it's very difficult to identify that this is a phishing email, this is a genuine email, email created by Gen AI, and this is a phishing email which is manually created. So again, with the type of malware, same thing is happening. Ransomware, it's becoming deadly, and there's almost like ransomware attacks happening in multiple parts of the world quite frequently. And now with AI-driven ransomware or Gen AI-driven ransomware, it's very difficult to identify ransomware threats. So ransomware is a major cause of stress among the different companies, particularly the C-suite level employees. And of course, this is a report based on the survey of nearly 650 senior cybersecurity experts, and mostly they say that ransomware is the main concern of the C-suite. Deepfake, this is an example here where this happened like a couple of years ago, where an executive from a company in Hong Kong lost 25 million companies' money in a deepfake video conference scam. So he received an email supposedly sent by his boss, which asked him to transfer 25 million Hong Kong dollars to an account for the client's payment. And he got suspicious and he asked for his boss to come for a video chat, where the boss came on a video chat. Apparently, the boss said in that video chat, yes, please transfer. And he thought, yes, he was talking to the boss, and he transferred the money, only to figure out that the video chat was actually Doctor. It's a botched up one. It's a fake video, which is created by the deepfake thing, and he was not really talking to a boss at all. So, and this is how this company lost 25 million. And it's like there are a lot of such examples of deepfakes and the havoc they're creating. So how can Gen AI enable cyber defense? Because organizations can actually benefit by incorporating Gen AI-enabled cyber defense to safeguard their systems. So they can help. This can help for the threat detection, predictive analysis, automatic response, and so on. So like ChatGPT, let's say, for example, can be trained on extensive data sets to understand this kind of cyber threat intelligence. So moving ahead, ChatGPT, let's say, or can be utilized for this kind of training on the cyber attacks. And then, of course, like companies can utilize that, okay, to generate cyber defense mechanisms as well. Just an example I'm saying. So, and this is a huge market, as you can see in that in the graph I'm showing. It's a huge market moving ahead. It's almost nearly 300,000 USD. So it's a big one. So how the generative AI can help in the cyber defense? So currently, what's happening is that like a company without any generative AI cyber defense, it can do up to a certain level, okay, to prepare for an attack, to identify an attack, to contain an attack to a certain part of its system, then to eradicate an attack, then recover from that, and can have a feedback mechanism. So these red dots, these light red dots and the deep red dots and the complete red dots, they actually show the impact. So if it's a very much light red dots, it's little impact. Deep red dots are the moderate impacts, and the high deep red dots are the high impact. So currently, without generative AI, all these impacts are quite little. Okay, as you can see here, preparation for an attack by a system is little. Identification of an attack happening is little. Containment of an attack is little. Eradication little. Recovery and lesson learned is all on the little side. But if you want to have a full potential of a system, then it's better to use the generative AI. Okay, and that can really help out and can shoot the efficiency of the system, as you can see. So you can have a better preparation to underline and then eradicate the cause of this kind of cyber threats initially. You can identify better that a cyber attack is happening. You can contain the attack better into a certain part of the system, eradicate it easily, and recover it with a much efficiency. And of course, you can have a good mechanism of feedback, okay, as well, to improve your system. So that's a good understanding of how Gen AI can help out in the cyber defense. So what's the current status of cyber defense from the Gen AI-enabled cyber defense, and what's the future look like? So Gen AI can proactively help in the cyber defense of organization. However, it's like quite early stages, I must say. So it can do any of those things. So proactive cyber defense using Gen AI, it can automate the security checks. Okay, it can simulate attacks and real-world scenario for the staff and to understand better that what kind of attacks might happen and in what situation and what to do. It can do good level of threat intelligence and predictive analysis, and it can do network monitoring of the whole system. It can do proper incident response, okay, in a much better way to take care of the attacks. So anything of those can be done. I'm not really going into in depth of these things, but like cyber defense with the help of Gen AI can be really good to counter the Gen AI crafted cyber attacks. Okay. So what are the challenges to overcome on the GenAI-enabled cyber defense, and what are the best practices that organizations can follow, which they're already started to do anyway? Data quality and bias in data. So of course, like when you're trying to simulate something and then understand how GenAI based attacks can happen, and then what can be the cyber defense mechanism, you have to train your model properly. If there's bias in the data and the data quality is not good, of course the training will not really show proper results. Okay. Adversarial attacks can manipulate GI systems through carefully crafted input to produce erroneous output. For example, if an attack kind of like hijack your system, they can input some noise in the system very easily, and can change your input into some malicious input. So if there's some malicious input in the system, it can easily produce malicious output. Okay, that's what this example says. Then, of course, ethical and legal concerns are there. There has to be some proper regulatory framework, which is still lacking. And there's like no universally accepted framework worldwide on this kind of thing, although different countries are working on their own ethical framework. Resource requirements. Organizations face challenges in resourcing for GenAI cyber defense because these are resource heavy. For example, if you want to use cloud-based resources or distributed computing framework, it's like quite heavy on the investments as well. And then they have to continuously monitor and evaluate the research usage to ensure cost effectiveness and scalability. So resource requirements are quite high, and of course, it's like quite heavy on the investment. So not many companies can actually thinking or like doing that. Integration and compatibility. Of course, companies already have their backbone network. Company already have the cyber systems running. So they have to kind of upgrade and then integrate the GenAI enabled cyber defense mechanisms with what's there already. They cannot just like say, okay, from today onwards, I'm not using my old system anymore. I'm just like creating new ones. So that doesn't happen. So of course they have to collaborate, and so the new systems must really collaborate and be compatible with old systems. Staff training is the key. Majority of the attacks happen in organization because of like staff issues. So for the staff training is the key on that. So what are the key takeaways for generative AI enabled cyber defense? And as I said, so multiple organizations have started to embrace GenAI for the cyber defense, but again, like too many challenges are there to overcome. So this diagram shows that on one hand, attackers can use generative AI, to weaponize and then like launch multiple different cyber attacks in a much deadly way. On the other hand, people working on the defense mechanism can use the same GenAI, mechanisms to craft robust cyber defense mechanisms to prevent these attacks. So, of course, it's the role of GenAI in cybersecurity is actually gaining traction every day, and its importance every day. And so if we see the number of jobs coming out, both in the cyber side and the applications of AI, GenAI, and now AI agents, it's kind of like going side by side. Okay, so in our School of Computer Science, we always say, okay, so either you are a cybersecurity or you want to work on, on the application side of AI and GenAI. Go ahead and there will be some jobs available for you. And of course, currently in the Kuala Lumpur sector, there's a lot of like startups happening on the cyber side as well, working on the GenAI things. So these are just some of the few examples of the GenAI powered cyber defense tools. Some of these are quite early stages, and some of these are already being used heavily. So like Global Cloud Security, AI Workbench, Microsoft Security Copilot, quite used nowadays. CrowdStrike, quite used nowadays. Cisco Security Crowd, SentinelOne. So some of these are still in the early stages. Some of these are already being utilized by the different companies. Having said, one of the big challenges that we see is that mostly our small to medium scale enterprises, which doesn't have enough money to kind of like spend on the cyber defense side, and they are the most vulnerable at the moment. So Taylor's, we are working on the consultancy side with such companies, okay, trying to develop small systems. So here, I'll just like show a small snippet of a system that we're working. But before that, an example here is the world's first multi-agent security technology developed by Fujitsu. This was late last year, which came into existence early this year. So it's kind of like collaboration of three AI agents to protect against cyber attacks, before they occur. So that's what developed by Fujitsu. So these AI agents specializes in attack detection, uh, attack defense, and then like business continuity testing, and that can enable the organization to address vulnerability and new threats proactively. So this is also an example of how an agentic AI actually works on the cyber side. So let's say like the attack AI agent, they simulate the different attacks, and then of course like the defense AI mechanism agents, they come up with the protective measures to kind of prevent and eradicate these attacks. And then the test AI agent, they actually test the whole thing happening. So this is the workflow diagram, as you can see here, that's been created by Fujitsu. And so I'm not really going in depth, but this target generative AI systems are being tested. And of course, you have the vulnerability database where the LLMs are there with the vulnerability data. And there is another big data set with the list of vulnerabilities, okay, as well. And there are some guard rules, okay, which is the LLM guard rules, which works on these vulnerabilities. And the agents call these guard rules and then call the APIs of these databases. Okay, so this is again a listed version of the different research topics that people can actually work on the cyber defense, cyber security side. Any of these topics can be enabled by GenAI these days. So if we see like the different types of research happening on the cyber attack, cyber defense, it's mostly from these topics overall. Okay, moving on. Before I wrap up my talk, this is an example of a case study where we created a small intrusion detection system using generative AI. Again, this is part of a project that we have done with one of the SMEs here, okay, who doesn't have any kind of cyber defense mechanism at the web. At the moment, they have just got like very old firewalls and those kind of things. So, and they cannot invest money to, on the expensive cyber defense mechanisms which the bigger companies are offering. So they have come to us and they have asked for a help, and like we are trying to create a whole cyber defense mechanism for them. And this is just a snippet of how we are creating an intrusion detection system, which is actually working now using generative AI. So I'm not going to divulge the whole thing, but just a small example here. So what we tried to do here and what we did is trying to use machine learning and Gen AI to detect the anomalies in the network traffic data. So this particular example I'm showing is just on the basic codes that we have used to do that. Of course, the advanced version is like much more capable of doing things. So here we tried to build an AI model that can distinguish between normal traffic and attack traffic in a given data set. That's how we initiated the whole process. So we just wanted to see in a data set of traffic, can we identify which are the anomaly or the attack traffics or the threat traffics and which are the normal traffics. So we use the UNSW NB15 dataset that contain network traffic data with features like IP addresses, ports, protocols, session information. And we have like two different traffic classes: normal traffic, class 0, and anomaly traffic, class 1. This anomaly class 1 has got 9 different subcategories of the anomaly traffics: DOS exploits, generic reconnaissance, shellcode, worms, backdoors, and so on. So this is just a glimpse of that LLM, data set that we used. And traffic class distribution, we have got normal and attack traffic. So of course we use the Gen AI framework, the autoencoder, and So in the intrusion detection context, the autoencoder learns to generate or reconstruct the normal traffic or the normal behavior from the input traffic. So how do you sorry, how do you understand like which is a normal traffic and which is anomaly traffic? So of course we try to look at the reconstruction error, right? So of course this model that we created was trained on the normal data, which is the legitimate network traffic data, and the model then struggles to reconstruct the data that is abnormal. So the model can easily reconstruct data based on the normal traffic, but it struggles to do when the traffic is not normal. So that's what we can understand is intrusion or attack traffic happening, because the attack patterns differ significantly from what the model learned as normal. So this reconstruction error actually gives us the idea where the anomalies are. So the model's ability to reconstruct normal traffic is what allows it to detect anomalies. If the model cannot accurately reconstruct the input traffic or the normal traffic, that means the reconstruction error is quite high. That can suggest that the input data is different from the normal patterns, which might indicate anomaly or intrusion happening. That's how we approach the whole thing. So the detection of the anomalies is the difference between the original data and the reconstruction data. That difference is what we call the reconstruction error, and that is used as an indicator of the anomaly. So of course, if the reconstruction error is quite high, it can suggest that the input is not following the learned normal distribution, and it's a potential intrusion happening. So we prepared the model, and of course, like we have the steps of data pre-processing, and then when you train the model, we have got the training of 80% and testing and 80%. That's how the data split happened. And this is done in Colab, a little bit of the snippets that we used. Again, this is a very early version of the code. There's a lot of changes happening after that. And of course, we have the autoencoder, and I'm not really going in that. And this is the model summary. Some more codes here. And when we train the model, we train on the normal data to learn a normal representation, 50 epochs, a batch size 64, and optimizer, Atom optimizer. And of course, Colab 800 GPUs were used. So just some training data here. And of course, what you see is that the 95th percentile of the reconstruction errors is chosen as the threshold for anomaly detection, which means that the top 5% of the samples with the highest reconstruction error are flagged as intrusion or anomalies. That's how the whole thing happens. So anything with the 95th percentile of the reconstruction error or below, it's fine. Anything more than that is flagged as anomaly. So some results here. So the conclusion is that, like, this is, as I said, this is a small study to demonstrate that Gen AI, such as autoencoders, can be applied in intrusion detection. The results highlight both promises and challenging using and challenges in such techniques. We use variational autoencoders. These are quite easily used for anomaly detection. However, deep encoders, autoencoders can also be used. Now, this is again a very early version of what we did. We showed here. We actually modified and then refined the whole process. It's now running in the client side, and like we are trying to add like more to the system so that you can identify more such attacks as well. Okay, thank you. I think like that's in my talk here. That's my email ID. I'll be happy to to kind of like answer any emails if you have got, and any interest on the collaboration sites are welcome. Thank you so much.
Yeah, thank you very much, Doctor, for your wonderful talk regarding this the use of agentic AI in cyber defense. And it was very much helpful for us to go through that, how you have made it in the real time, and also with the intrusion reduction, and how the agentic AI is better than that of the traditional AI concepts. It was very nice to have your session, sir. So any of you have any doubts, kindly ask, sir, about your doubts.
Thank you for the interest. I really appreciate. Yes, I can see your hands up.
Yeah, good evening, sir. This is Kokila from PES University.
Hi.
Yeah, hi, sir. So I have three questions. I just want to tell you that. First question is like, when we are working with the Gen AI kind of capstone projects, how do we evaluate it? And if we are creating our own pipeline through Gen AI tools, our contribution is somewhere missing, I feel, even though we do fine tuning and we have our own pipeline. The major question comes when we are submitting the research paper is what is our major contribution? Because we have existing API, that is one of the question that is frequently asked. So this is my first question, like how do we evaluate and how do we register our contribution when we are using the APIs? My second question is, suppose we generated an application through Gen AI tools and we do have contributed on fine tuning it and some other way. Where could we deploy it as an open source things, or how can we explore, or how can we enhance it? So that is my second question, like where and how we can deploy it. My third question is like, we do have antiviruses, right? So this was the major cause because is attacking the system. We have a very big business back behind the antivirus. Likewise, in future, could we expect something like some software like anti-AI software?
Okay.
So this is my three major questions, sir. I hope you will answer for it. Thank you so much. Your session was very engaging, very interesting. Please continue the same, sir. Thank you.
Thank you, Dr. Kokila. I appreciate the questions. Now, we kind of like use GitHub, okay, to upload things, so you can actually try that. And I know that a lot of my students they upload things on the GitHub, and there's a full-fledged community running on GitHub where people help each other as well. So currently we are working. Let's say we are working on like 2 or 3 projects on the consultancy side, where we are working on our industry partner and their partners from overseas as well. So we are all collaborating through GitHub. So that's of course you can try out, and it's not very difficult to do that. It's quite easy. Like once you get accustomed with GitHub, and of course GitHub is actually kind of like flourishing every day, and then new features are added every day. Yeah, on that, quite helpful, I must say. On the third questions, yeah, there's an interesting thing. I mean, of course, like whenever I go to conferences and talks or events, there's always this thing. Okay, with the way things are changing, advent of AI and Gen AI, now agentic AI, then quantum AI, and then God knows what's coming more. What kind of like what is it? Is it really helpful or like healthy for the community as well, for the society? Yes, there are been talks on things like that, but what my experience says is that like whenever you talk to people from the tech side, they are mostly into the pro side of AI being used, and then whenever you talk to people on the social and other things, they talk about the other side of AI. Uh, uh, so currently we, for example, we collaborate with our School of Liberal Arts in a way, and our School of Social Sciences, so on certain projects in a way which has got AI elements in it. This thing is a kind of a debate that, of course, like we hear from the social sciences people, and like one of the projects that we have just applied for funding from the government agency here in Malaysia. Still, social components, including on kids and including on the aged people and things like that. And a lot of these, let's say, a lot of this like cyber, I can't say attack, but the cyber mishappenings are, including, theft of passwords, theft of like bank information, everything. These things are happening mostly with the aged people these days, where people doesn't even know what to do. So, for example, like so last year, of course, I got a call from my dad. Uh, in last about 1 year, it was very exciting. I mean, I have received this many amount of dollars in my account. And then like I could not even make him understand that this is a fake email, so do not even click onto something. He was not really ready to even understand that. Okay, and this is a very common challenge among the elderly peoples. So this is like one of the biggest example of how AI can be deadly for a certain part of the society, including the kids. So yes, like moving ahead, there could be some kind of anti AI system. I don't know, but the way things are changing, yes, it may be useful to have something like that in future. At least when this emotion AI and those kind of things will slowly come into play. Uh, and the first part of the question that you asked is, I must say, is a bit tricky. We also face similar kind of issues, but so the way that we do the capstones here, most of our capstones are done with industry as like short-term internship kind of things. Very few are done inside or like local or domestic. So one of the advantages we have is that like when these things are done by industry, they kind of like say in a group of like 3-4 people, if they're working on that industry project, they kind of like distribute the things, and this like it's like time bound. So people have to follow it, and that makes life a little bit easier for our lecturers as well when they come evaluate and mark. But we also ask for kind of a self-reflection of like what everyone has done and contributed in the project. I mean, for example, at times like what we do is that we kind of like create small teams. For example, 3 to 4 people. One becomes the project manager, and that person has a responsibility to manage everything in the project, manage the people, allocate tasks, including himself or herself, timelines, deadlines, milestones. Everything comes to that person. Some of the other person becomes the programmer, some becomes the designer, some becomes the tester. So that's how like we try to do things. Again, it's not a very robust thing always, but like more or less working okay for us. Yes, that's I can say. Did I answer you, Kopila?
Yes, sir. I got the points. Thank you so much for your patience and for your explanation.
Appreciate. Thank you. Okay, I can Shankadeep.
Okay, hello sir. Am I audible?
Yes, please go on.
Okay. Thank you, sir, for the engaging session. Uh, uh, Sir, I want to thank the entire institute for this opportunity to be here, for accepting the request actually for the last minute. Sir, my background is entirely social. Few technical background is there, but I'm now currently working scholar in the agriculture economics as well as in the management sector also. So my humble question is that if we want to make a few kind of apps or models, specifically the models in the field of agriculture related to the like predictive models, how can they based on few variables, if they apply those, they can increase their productivity as well as their profits. So any kind of models, if we want to develop, having the background of social science, how can we do it? What will be the starting point? Do you need to collaborate with the technical guys, like a technical persons, or like how?
Thank you, Shankadeep, for the question. Okay, so first of all, there are so many models now available, and they're like open source models. You can have the different tools where these models are embedded, and you just have to use them. Okay, so personally, I see very little requirement to create a new model. Okay, you can actually utilize any of these existing models. That there are models available for agriculture. I don't use or work on the agriculture side, but I have got like people who actually work on the plantation side, and so there's a very big like palm oil plantation things in Malaysia. So I've got like people who are working on the technical side of those things, and then predictivity and the predictive analytics and other things of the palm oil. So they are just using the models. They are not really creating new models. So they are just applying the models to do certain things. I think that's the easiest way to do, unless you want to do something very new and you don't get a model for that. Yeah. So
Thank you very much, sir.
yeah, so you can actually kind of like
Yes, sir.
collaborate. Yes, like as a social scientist, you may not really know exactly which models are available and then what's to use. But if you kind of like collaborate with people who are quite knowledgeable and pro on the technicality, of the machine learnings and this kind of Gen AI, they can help you out with the models, I guess. Yeah.
Thank you very much, sir. Thank you very much. And thank you very much, sir. I'm from the University of North Bengal, sir.
Okay, wonderful to know that. Yeah.
That's why I said thank you, Dada.
Thank you.
Okay. Thank you very much.
Yes, I can see one more hand, Kirti. Yeah.
Good evening, sir. Hope I'm audible.
Yes, please. Yeah, go on.
So, I'm currently based in Bangalore. Okay. So, my question was somewhat related to practical and interesting facts. So, currently, my research work it deals with advances in intrusion detection systems. So, we tried deploying the hybrid learning models that integrated ANN, LSTM networks, and ensemble classifiers like random forest, XGBoost, and light GBM. So these models were effective in combining both spatial and temporal features, learning with various robust classifications, where we were able to tackle the complexity and imbalances which are present in the modern network. So it was evaluated on KDD99 dataset, that is a very classical dataset, as you may know. So the approach was to increase the accuracy and detect performances against various real-time intrusions. So my first question was, given the strengths of the transformers in capturing all the long-range dependencies through self-attention, so how can these models be effectively integrated with all these existing hybrid architectures like the ENN, LSTM, and ensemble classifiers, so that we can improve the real-time intrusion detection accuracy and also reduce the false positives. So especially in imbalanced cybersecurity datasets like KDD99. So this was one question. And the second was, yeah, so this was the main question I wanted to talk about.
Okay, thank you. So if I may ask you, what's the context that you tried these things? Like, for example, is there certain certain platforms that you wanted to try? Is there certain output that you want to get out of this? So what's the context?
So basically, with the current intrusion detection models, which I identified, which are present, they only deal with certain kinds of attacks. So our aim was to build an ensemble model with all emerging models, like emerging classifiers, emerging ANN, LSTM models, so that we can identify various types of attacks which are not specifically just to one zero-day attack. So we wanted it to be diverse.
Okay, using like only one model.
Yes, we tried integrating it. We couldn't test it on the servers because we had some privacy issues.
Okay.
So,
is it a research project that you're saying?
Yes. So it was my MTech research project.
Okay. Yeah, because I was curious to know that like what kind of of a technical real world project that actually allows you to do that. Because like every single company, when they try to do that on a certain eyeing for a certain output, there is always a limitation. So when you say that you are trying to use one model for everything, I was a bit curious to know more. So technically, yes, it will be difficult, I can say. Okay, more on the resource side, and I'm not sure what kind of platform you have to use to have one model that can do everything. Okay. But when you work with the different companies like what we do here in Kuala Lumpur, the requirements are kind of like certain things that you have to do. For example, this thing what I showed, they had a requirement. Yes, like you have an IDS which will try to identify any kind of threat traffic, let's say kind of a malware or a little bit of on the basics of the ransomware. If you can identify a little bit of the phishing traffic, so these are the small requirements they have got, which is then you can implement. But like what you're saying is that you need to have you're trying to do one model to do everything on the IDS. Research wise, you can try, but constraint will be yes your platform. So what platform are you trying now?
It's a half-done work. It was my final year thesis for MTech. So
Okay.
we tried it. So it was a Python environment. We tried it in Notebook. We tried it in Spider. We tried it in Google Colab. But we had GPU constraints, of course.
Yeah, of course, I can
So
understand that.
we were only sticking to KDD 99 dataset. And I was looking forward if I can extend that work and try it or simulate it. I tried simulating it with certain data points. It showed a good accuracy, but then apparently there is a difference, or there is a gap to bridge when we have an accuracy of 99%, but we have deployment issues. I hope you agree to it.
Yeah, I can completely understand that because of course that's what I'm asking the platform, like what platform are you using?
So we had limitations
deploy.
because
Yeah.
we were doing it in the university level. We tried integrating with the company I worked with previously, but then we had privacy issues so.
Right. So of course, I mean, I can try to find something for you. I mean, if you just email me with some details, okay?
Definitely.
Yeah, but yes, like so the constraint with GPU is a well-known constraint, and then we also face certain constraint in our university. So of course, again, like it all comes down to I guess like availability of the platforms and how much the university you're working or the company you're working is willing to invest to test this kind of things. But yes, like if you are trying to do kind of one model for IDS for everything, that you need some good good and robust platform to test that. Yeah.
Yes. Thank you, sir. It was
No worries.
enlightening.
Okay. Is that all? I think.
Yes, sir. There is one more person who raised it. Tisha Manna.
Okay.
Do you have any queries?
Hello, ma'am. Yes, sir. Good evening, sir.
Hi. Yeah.
Sir, I have two questions, sir. First question is how the agentic AI is different from generative AI.
Mm-hmm.
And the second question is how can we use the agentic AI for the predictive analysis purpose?
Okay. So if you can recall, the examples I've given, and it's like one diagram I showed where the agentic AI, were kind of like controlling the whole end-to-end process flow. So generative AI is mostly on the static side, static behavior. What it does is that it creates new contents, based on the input, and then starting the pattern of the input, it creates new content. But like what agentic AI does, it kind of like controls the whole end-to-end process flow of a system to automate the system. Okay, and these end-to-end process flow will have generative AI, which kinds of like queries. Understands the query of, let's say, like customer, as I showed in that example, and then like once it understands the query, it then kind of like throws it onto the agentic AI. Agentic AI then sees which agent can then handle this query, and that particular software entity handles that query. It talks to the API, get the answer, throws it back to the agentic AI, and then like agentic AI again like throws it back to the generative AI, which then kind of like sums up the query and then it sends a reply to the customer coming from. So generative AI, it kind of like creates new content, okay, whereas agentic AI is the whole end-to-end process systems that works with generative AI and works with the different AI agents, for the whole end-to-end process flow. Did I answer the question?
Yes, sir. Yes, sir. Thank you,
Okay,
sir.
thank you. Sorry, what's the second one? You asked two questions, I guess.
Yes, sir. Second question is, how can we use this agentic AI for the predictive analysis purpose?
Okay, I mean, so again, like agentic AI is the same kind of thing. Why do you do normal predictive analysis with like generative AI? Okay, you write some code which can act as an agent, and of course the generative AI creates new contents, and based on the queries given, it can predict. So basically it's nothing new, so you do the same thing what you do. The only thing is that for agentic AI, if you have multiple different parts of a system, for example, what I said in my example, so it's a booking system. Let's say it's a flight booking system. Okay, so there are multiple agents running. One is kind of booking the system, one is doing certain thing, third one is doing certain things. So agentic AI basically just like clubs them together. It has got nothing to do with the predictive analytics side. That's been done as normal.
Okay, sir.
Yeah. So if you have understood how the predictive analytics thing works with Gen AI, it's the same thing for agentic AI. It doesn't do anything on that side. It basically just like clubs the different different component agents and Gen AI together for an end-to-end process flow.
Okay. Okay. Thank you so much, sir. Thank you, sir.
Okay. Thank you. I think that's all.
Yeah, we can see too much of participants having an active interaction in this online session too. Thank you
That's
very much,
interesting. Thank you.
Doctor. Yeah, it
Okay.
was almost 12 o'clock for you, I hope so.
No, it's like 10:40 p.m. Yeah,
Okay,
yeah.
10:40 p.m. Yeah, it was very happy to have you, sir, because after so much of late hours, you're being here in this FDP, and you have given a really a good direction regarding the research work and how to carry on with this generative and agentic AIs. You have given a lot more information to our researchers. I hope so. Hopefully, I
Thank you.
think
Pleasure.
all our participants who are actively participating maybe getting to know about how this is happening and how to work with generative AI and agentic AI. Thank you very much for your presentation, and also the presentation was also very much interactive and very much colorful to know about how this happens. So the presentation was very good, and even the things you addressed, the questions as well as the content you delivered was really wonderful enough, sir. Thank you very much for being here, sir. And certainly, if any of your participants is in need of your details, can be shared with them so that they can communicate
Yep.
with you.
Thank you so much, Dr. Anita. So I've just like wrote my my email ID on the chat. So it's Sayan dot. So I'll just write it again.
Okay.
Sayan dot Ray at Taylor's. Yep. So that's my email ID. Sayan dot Ray at taylors.edu.my.
Yes, yes. Yeah, thank you very much, Doctor, for your wonderful presentation and contribution. And participants, let us have a claps to Sir so that we can show our appreciation to him.
Thank you so much. Really appreciate.
Thank you very much, sir. And
thank you to everyone.
yeah. Thank you, sir. And participants, if you are in need of his sir's mail ID, he has shared in the WhatsApp group. You can do it. Also, the feedback form and the attendance sheet has been shared to you people. Kindly give your input on the same. Thank you very much, Doctor. I will contact you very shortly.
Thank you so much. Really appreciate. So looking forward to some collaborations. Just feel free to email me. Just give me some time to reply because I get around like 200 emails.
I know,
200
because
emails per day, so I might be late, but I'll reply. Yeah.
No, you are very much actually very much answering to whatever the information we are in need of on time. Thank you very much for that.
Thank you
That's
so much.
why I
Appreciate
can have you here. Okay,
Thank you
doctor.
so much.
Thank you very much. Thank
You
you.
have a nice evening, all of you.
Good
Bye-bye.
evening.
Thank you,
Can you
doctor.
please share the feedback link?
Mm. Sir, is there any query you have, sir?
Hello, ma'am.
Okay.
Hello.
Yes. One second,
Ma'am,
please.
please kindly share the feedback link and attendance it because it is not accessible. This link is not accessible.
We will see. We will see to it, sir.
Please
And the participants,
send it
yes, sir.
in WhatsApp
And the
group.
participants kindly join by 8:15. Let us take some 5 minutes break, and you please join by 8:15 for our second session in the same link. Okay, don't shift your links. Use the same link for sharing, for attending. Rest queries I will address, sir.
Uh, Hello, ma'am. Anita, ma'am.
Yes, sir.
Ma'am, actually, I'm not at all in any WhatsApp group. Is there any
Yes.
WhatsApp group created for this?
Yes, sir. We have a WhatsApp group, and I was enabling that WhatsApp group link in the chat box every time I am doing it. Can you check it in the chat box, sir?
Actually, here I couldn't find anything in chatbots, ma'am. It is showing only real-time text only. It is showing. I don't know
Oh,
where it is.
okay. Then you do one thing, sir. Can you please ping me in the WhatsApp, sir? In my WhatsApp.
I don't know your number, ma'am.
Okay, sir. Uh,
I will tell my number, ma'am. I will tell my number. Please know.
no, sir. You know the mail ID, no, sir?
Madam.
My mail ID.
I've sent an email also to your email
If
ID.
you name, sir, your name.
It's me, Amudan. I've sent to Anita at vat.ac.in.
A Anita. Sir, can you share
Anita.
it again? Yes, sir. Share it again and request for the WhatsApp chat link. I will share it there, sir. Because
Yeah, okay,
too
ma'am.
many mails I'm receiving, but I'm trying to address everything.
Yeah, okay, ma'am.
Somebody Tanga Balaji Amudan. Isn't it, sir?
Yes, ma'am, exactly. Correct.
I am now I'm sharing your the WhatsApp link. Please check it.
Email.
Hello.
Yeah, in email, sir. Please.
Yeah, okay, ma'am.
Excuse me, ma'am, Anita, ma'am.
Yes, madam.
Madam, we are not able to access that link, madam. We are able to see the link, but we are not able to click on that, madam. It is real-time text.
Yes.
Where are you seeing that link, madam? Are you seeing in our
Teams chat?
In the chat box, huh?
Yes, madam. Yes.
Can you copy it and paste it? It's not
No,
possible.
you cannot copy that, ma'am. It is not able to copy also, madam.
Ma'am, same for me also.
Okay. Madam, please share me in your...
Ma'am, you can share it on WhatsApp group, ma'am.
Madam,
the chat is available, and the RTT feeds are there, which are being displayed.
Actually, it comes like a text, na, so link is not available to us.
Okay.
Whatever is being displayed is it is in the RTT field.
Can't copy the link. Can't copy the link from this real-time chat box.
Everyone is facing the same issue, ma'am.
Sir, okay. Madam, I will...
Madam, good evening, madam.
Sir, in that case, can I paste it in the Teams information, Teams chat also you can see, general meeting?
No, madam. No, madam.
Teams chats are not available.
Excuse me, ma'am. Team chats is unable, ma'am. There is no link and it is unable to us.
Ma'am, the
Teams
problem
chat.
is that there are n number of participants in our WhatsApp group, but we can see here only certain people are available in our Teams chat. Are you getting, ma'am? The number of participants.
Team chat is not available, ma'am. Team chat is not available to us. It is enabled.
Okay, then can you help me in the WhatsApp, sir, so that I will share you, madam? And sir, WhatsApp you please request, I will share you.
Ma'am, please send a feedback form and attendance in the WhatsApp group, ma'am.
We will do, madam.
Ma'am, good evening, ma'am.
Good evening, ma'am.
Ma'am, I'm Dr. Jeyanthi from Savita College of Liberal Arts and Sciences. Unfortunately, I am unable to get in through my personal mail ID, ma'am. So this is my daughter's mail ID, MM. So today alone, kindly excuse me, ma'am. Tomorrow onwards, I'll be joining in my ID.
That is why we are getting your mobile number, your mail ID, your institution, everything to match your presence, ma'am.
Okay, ma'am. And I'm also not in WhatsApp group, ma'am. How to join, ma'am? Can you please send the link to join the WhatsApp group?
Can you please mail me, ma'am? I will share you there.
Yeah, ma'am. Yeah.
Please.
Thank you, ma'am. Thank you.
Yes, and shall we have our session because it was almost time up?
Ma'am, hello, ma'am.
Yes, madam.
It's not able to open the feedback
Sir,
link
that
actually
I will check it, sir.
for everyone.
Chat information, I will check it, sir. Okay. Yes, ma'am. Somebody asking me.
Just
Madam,
tell me your mail ID, madam.
My mail ID is AANITHA. AA, ma'am, I'm writing my mail ID.
Yeah, madam.
Coordinator mail ID. Is that visible, ma'am?
No, madam.
No, madam.
No.
Madam, chat is not visible, madam.
Sir, I'm not sharing in my chat. I'm sharing in my screen. No, sir.
Screen, madam. Anything it is not visible here.
Not visible. 1 second, sir. I'm doing
Madam,
it again.
from this chat, na real-time text chat, we are not able to copy the link, and even
Yes, sir.
it's scrolling it down. It's
Sir,
scrolling
now
on.
is my screen visible, sir?
Yes,
Yes,
madam. Yes,
madam.
madam.
Kindly, whoever unable to get the WhatsApp information, kindly mail me here. We will communicate.
Madam, WhatsApp I am there, but I can't able to find any feedback link or attendance link. Yeah, feedback link not being able to work with.
Understood, sir.
In
Understood.
Teams also.
Understood. Sir, understood, sir. The thing is that since all are from various university, the chat was not enabled for many of the people. We will see to it and we will resolve it, sir. Don't worry about
Yes,
it.
madam. Can you please
Don't
enable
worry
this
about it.
Teams chat, madam, so that we will fill that.
I am have given in my team chat, but some people are unable to see. That is why you people are messaging me. What I'm asking you is, requesting you is, kindly um, give me an information in the WhatsApp message. The
I
problem
messaged you,
is
madam,
that
personally.
if you message
I
me
have one
personally, I will be
suggestion.
sharing it quickly. The problem is that,
Would it be possible? Excuse
sir,
me. Can I provide one suggestion? So what I suggest, you can create a QR code of the feedback form, and you can show that QR code. I think you can share your screen. We can scan that QR code. We would have the link. You can fill that up,
okay, sir, that is a good idea. I will do that.
right? All
Sure,
right.
we will do it. Thank you, sir. Thank you for that information. Thank you. Okay, so quickly, your queries will be sorted out. Okay, can we have our next session, please? Shall we?
Yes, ma'am.
Okay. I welcome you all for the second session. Vaishali, ma'am, are you available there, ma'am?
Yes, ma'am. Hi.
Yes.
Hi.
Ma'am, can you please turn on your camera, please?
Yeah. Am I visible, ma'am?
Yes, ma'am.
Yeah.
Yes, you are visible, madam, now. Okay. I will stop my sharing. You can start sharing your screen, madam.
Okay.
Okay. Welcome you all for the second session of today's. The topic is with the prompt engineering and optimization. And we have here our resource person, Ms. Vaishali, who is having 12 plus years of experience, industrial experience, and also working in research and development as senior engineer at Microchip. And also she is having a prior experience at ESAB, Swedish company, in product testing and development. Also, she has an idea with the project management and education and training. Her education qualification is with the MTech with VLSI design and embedded system at Madras Institute of Technology. And she has been a speaker for notable workshops, seminars, and FDPs, which was conducted in various around our India, like IIT Madras, VIT, MGR University, Panimalar College. In various places, she has given her talk, and especially in IIT Madras, she has done a talk on Python for business analytics. And in our VIT Vellore, she came personally, and she has given an offline meeting on deep learning and neural networks. And in Panimalar College, she was given a talk on machine learning techniques. And in MGR University, again, she made it with the deep learning and Python as a hands-on session. And also she was expertised in embedded systems, machine learning technique, deep learning and Python. So welcome you, ma'am, for the session. And participants, I hope that you will be enjoying the session, which will be shared by our resource person, Ms. Vaishali. Ma'am, over to you.
Thank you. Thank you, ma'am. So, hi everyone. I hope I'm audible. Okay. Good evening to all. As ma'am said, I'm Vaishali, a senior engineer, works at Microchip. And thanks for the intro, ma'am. Okay. As we all know, today we are going to see the topic on generative AI models and prompt engineering. Just give me a second. Okay. Okay. I'll share the overall agenda to give an overview. We will just talk about like what is Gen AI and what are the popular models and what is prompt engineering basics, what are the techniques of prompt engineering and the advanced strategies of it, what are the applications, how it is being used in industries and academic areas, what are the challenges and risk faced currently when implementation, and best practice how we can how we need to implement the prompt engineering and how it will work for the better, and what are the future trends, and hands-on demo little bit I'll show like what we have done and how it is being used in our day-to-day lives or the in our industries, how we are using it, how we are optimizing it. So these are the sessions which we will be walking through. I hope it's okay for you. And so before we go into deep into our technical course session, first we will discuss why we need an AI. As I think you have got a better intro before. Just to add on to it, I'll just make some present some statistical data of the current things, what is how it is evolving. So as we all think AI is a future, but I would say like artificial intelligence is no longer the future, it is already here. If you take the present statistic data, according to PwC means it's a Price Waterhouse Cooper, where there is a big, they call it as a big four, a professional service firm. According to them, who makes the global AI market, they predict that the global AI market will reach $1.8 trillion by 2020. Within 5 years, you see how much amount they are planning to invest. And MC Kinsley, they also report that 70% of the enterprise are already piloting on the generative AI. It is not like they will implement, it is already they have started implementing the workflows into that. And in education sectors, also they have predicted like the 40% of the grading system, like now teachers or the lecturers, they are doing both the grading system as well as the teaching things. They suspect like the 40% of the grading system can be automated. I mean, like can be implemented using AI, so that teachers can more focus only on the students than focusing on these things. So these are all the insights. So it is our so I would say like apart from these things in engineering field also, if you take the companies like Siemens also uses the AI to cut down the design cycles by 25%, which is faster innovation and productive product purpose. So the design itself, we had the we had a big team to make a design things, but now by using an AI, they have cut short all the people, like up to 25% they have been cut short, and it is they getting improvised it. So what does it all mean for us? It does mean that AI is not a part of our passing trends, it is just becoming a core skill, and I think we need to learn and grow up on it. So if you take the embedded engineering people, there will be a lot of people and there are expertise in many people. So similarly, apart from the core, we need to also, irrespective of the departments, we need to also learn on the AI. So I think you will all go hand in with that. Okay, so walking into our thing. So first we'll talk about the Gen AI. So before going to the Gen AI, we will just see the evolution of an AI. So when you see the evolution of an AI, first they have the rule-based AI system. Like if you open in any chat or like any website, there will be an automative response saying an hi so and so your name, and they will just respond back. How it is made, I would not say it as an AI, but if you take it as considering it is a rule based one, where if particular command comes, if a happens, do a B, or if B happens, do a C, or if C, ask something else. So they have a fixed or a specific set of instructions. So based on this, if this particular instruction comes, then provide the next instruction. So like that, they have a rule based format. So that was the initial one. Then later came the machine learning part, where in machine learning part, instead of rules, we gave them AI data. It learned from the patterns. Like if I give the group of cat or dogs, it will learn from the patterns, and through that it will help to detect what is a feature is, or what is the animal is, like that. So based on data, it was trying to learn from it. For example, like detecting the spam emails, that was one good thing which was done by machine learning, where it helps to it was able to understand based on existing mails, and it was able to detect the spam emails. Then later came with the deep learning part. So in the deep learning part, it is inspired by brain. As we all know, it is like a process the complex data like images and voiceover, and that how it recognize like a face recognition, what we do in our phone, or the voice recognition. All these comes into the deep image face recognition comes into the deep learning part. Then comes the transformers. I will say it was an breakthrough that allowed AI to understand the context. This powers advanced language tools like Google translators, and also the foundation of ChatGPT. In my view, I would say. So for example, the Google translator understands the phrases and not just words. Before it was like it was a bag of words was just being understood, but now it is like it was helping to understand the phrases. Even if you just give some phrase, it was able to understand it. So that was our major milestone. Then came then we have now into the era of a generative AI. So now what a generative AI could do, now we can able to create our own data. I mean, it can able to create our new text, images, code, music, and even some designs like a PCB design if you take in the easy part, or the CAD designs. So even the hardware design, the simulation of the hardware design, all those things can be made by the generative AI. And as you all know, we have some well-known tools like ChatGPT, DALL-E, that is like for image processing, and the Copilot, and all these things are being extensively used for these things. So I would say, like on the whole, AI has grown from just following the rules to learn to the learning patterns, and to also understand the context, how the human will interact, what it has to give, and how we can generate a better output from the, because we have fed all our data. So how to generate a better text, all those things we need to know from our side, like what question if we give, how the AI will respond it best. So all these things we need to learn. That is a part of prompt engineering that will come into the later section. So this is all about the evolution of an AI. So when we come into a generative AI, as I said, first it learns about the patterns from a larger data sets. Then from that, it produces a new output like a text or the images or the audio or the code, whatever the user need. So the major difference, if you see, all the previous model were like it just predicted when you take the machine learning and other things. Whereas here it creates our own data based on the existing data. So that is nothing but a Gen AI. Then coming to okay. So I think we discussed most of the things. As I said, here the generative AI is transforming the software development, used in software development. Also the product designs, it has been used, simulation and automation perspective it is used. And this also goes beyond the analysis. Previously, we were just analyzing the data and making prediction. Now, as I said, it creates the data. And also, because of it, what is the use for the industrial industry, or if you take any sector, what is the main purpose? It boosts the productivity. It helps the people to work faster. And also draft, for example, what like drafting the document, writing codes, designing prototypes, and other things. So, and also unlocks the creativity. It is not limited to specific logic. Before, we used to learn some theoretical concept, and sometimes we might understand or we might not understand. So the logic implementation we can able to know by step by using the different tools. And also it can spark new ideas. So when we understand better, it helps to spark new ideas, and also it helps in innovation things. Accessible to everyone. You don't need to be a programmer. For example, I think in the previous session, someone asked like they are in different field, but they want to implement something. So you don't need to be a programmer in this case. Like you can use the different tools like GPTs and other tools. Also, there are many other tools which you can use it. All you need to know is a basic of Python and what are the libraries or the models you need to import to make it work. And based on that, you can make your own GPT, and you can use it for your business purpose. And also the other thing is this, I would say like companies are already integrating with it. For example, if you take if you for example, I'll say every company is working on integrating their tool with the generative AI. If you take a max touch or okay, you people will be knowing about if we are easy students, you will people will be knowing about the MATLAB. Like that, we have a Max Studio, and there are many other tools. What each tool they are doing is inside the each tool. Before it was like just a tool. Now they are trying to put in a GPT inside it, so that we can able to interact with it. And it is not like a general GPT, which is like what we have outside. They are trying to integrate inside the software, so that that GPT will respond each of your queries. If you ask any queries regarding your MATLAB, or if you are asking any queries how to flash a board when you are using a Maxtouch tools or something like that, it will helps to say like okay, this is a so and so procedure. Before it was like they have instructions. In the previous things, we had instructions or the documents we had, and there will be a videos. But now they are using a interactive interactive GPTs. They are inbuilting into the software. So I think these are the major milestones which we will have in the upcoming. And it is not like it is not, it came, it is already there. The only thing is like they are working on, and they will mostly like in 1 or 2 years, almost all the high-end software tools will have these things. And the models, okay, when before going to the models, and one more example is like I think many of you people will know this. Coca-Cola company is using DAL-E with the Chat GPT, and making a camping that allows the customer to create and visualize their own ad. So the ad camping can be done by the customers. That this has been automated by using the you see the Coca-Cola industry has no interlink with the AI. That is what we think, but they have already integrated things, and they are starting visualizing things how it can be done better in their own field. Then the NVIDIA and BMW is using the AI powered digital twins to design the smart factories before constructions. So as a pre-model, they just before the pre-model is made using the AI, and based on it, after the design, they are implementing, which is a very good uses of an AI. So on the whole, as you all know, it can help in language conversions, or image building up, or code generation, audio and video things. All these things in different format it suppose, and each one specialize creating it new things in its domain. That is why we see AI writing their essays, paintings, art, and composing music, and even making movies are possible using the AI. So when coming to the models, so they're trained on a massive data, example like text, images, and code, as we all know. So how these models work? First, the input is given as a massive data. Once the input is given, it recognizes patterns in the data. Once the data's patterns are being recognized, it generates a new output that looks original but are based on the patterns they learn it. So that's how it creates its own new it creates its own output. It's not like just a copy paste from that extract already given information. So for example, when you take this, ChatGPT plays a major role where it writes an essay. In image, mid-journey we use, and also it also generates the logos, and it helps in making the designs, logo designs, or any other designs. And for code, we mostly go to the use Copilot, and the DeepSeek coders are being used. And for videos, we have this Sora, and also for audio we have Junkbook, and Whispers we have. So it creates, in case of a video, it helps to create a realistic simulations. In case of music, we have the AIVA, and which compose the background tracks. These are some of the models which is being used, but there are a lot more. I think you will know better. So when, as we said, the use cases helps in the production, R&D, also in helping in the simulation and the customer facing applications. In these spaces, they are being quite useful. Then comes, we will go deep dive into the each and every model. First thing is like a text based large LLM model. So in this first, when you take this text-based large LLM model, what they are, AI systems are trained on massive amount of text. They might be books or the website articles, codes, etc. They predict the next word. Actually, if you type something and if you ask some relevant question, it actually predict like is it interlinked to the previous question or it is a separate question. All those prediction is being done very effectively here, which allows them to generate an entire paragraph or a dialogue or even or a document, as you all know. And they don't think like a human. They are excellent at recognizing the patterns in languages. I mean, like even the different languages they support. How they work? So as we said, they are trained based on the billions of words, predict the next word, they generate the text, and how it is being done using a neural network transformers, like they learn the grammar, meaning, and the context, and they interrupt it, and they give the output. So, for example, the text of LLM, if you take like powers of GPT, focus on reasoning and multimodal abilities are being possible. Safe and ethical AI assistant of can be used. We also have an open source large language models, which all supports, which all it's been done by the LLM. I have listed few in the PPTs. Few models of which supports the LLM. So what are the main applications? So application, if you see, as we said, it helps in summarizing a lesson, tutoring, and grading assistance. In the business things, it is like drafting the reports, generating and marketing content, analyze the data. In industrial perspective, especially if you say like it helps in code writing, though it doesn't give a perfect code, but it helps in the code writing, and also it helps in debugging. And also in the documentation purpose, it is very useful. In customer service, as you all know, chatbots, email replies, and support automations can be done. In creativities, like you can tell even the story, you can ask them to tell a story, write a script writing or a brainstorming ideas. All these are the different applications of the LLM. Then going to the next thing is like the code based code and engineering model. So in these things, if you see, it turns a okay, as I said before, so it helps to analyze the requirement and turn the API into a skeletons or the test and the README forms. So in those ways, and also it helps in generating the code. And in form of automation, it's like it helps to automate different. It helps in simulation, generating a simulations, as I said. So before it has been implemented, you're able to see a simulation like how it works. It is a very effective tool, right? Then, as I said, it is used in CAD feature scripting, where generating the design constraints and the material or DFM checks, it can be done in the CAD based things. And also like a review of a code or the review of the document, it helps in doing it. So these are the some of the different things I have listed in the PPT. Also, you can have a look at it. And if you think there's a multilingual, it doesn't mean like it supports multiple languages. I mean like it supports it understands any kind of a programming. So in those ways, it has been very useful when you take the code and engineering automation models. What are the okay? Also in terms of image generation and video generation, as we covered before. So if we give an if I in Gemini itself, if you take like if I give if I say like a generator image like a person working in a system or a computer with a PC, it will generate an image. So it is automatically help to make an image, and also a video generation is also possible using these models. We will see some example of how to even audio, like how we can interrupt the audio, and how we from the audio how we can generate a text in the later part of the session. But I'll just go through the high level of slides now. Then when it comes to the engineering and specific generative Gen AI platforms, as I said before, Siemens and NVIDIA are working in the real-time simulations like digital twin, which we talked before. They were able to simulate it before it has actually been implemented. Then Autodesk AI are being implemented. Autodesk AI is being made especially for the CAD tools, and even the ABB company is being using in the different robots. They are trying to implement AI so that they can analyze and they can do the task by themselves. So Gen AI. Okay, before going into this, what are the high use case if you take it helps to generate the unit or integration test generation and covers the gap. For example, there are like 5 test cases, or there is a one scenario, and if a human writes it, they will write a 5 positive test cases or 5 negative test cases, but AI can cover even a multiple test cases, or even like it will cover nook and corner if you give a pop-up prompt and other things. Also it helps in refactoring, like API migration it helps. And when API migration to implement just API migration or the dead code removal, like a refinement code refactory, they will say if we are doing such kind of activities, they will implement a specific team, or sometimes it will take months to do that. But using AI now, these and all are made very easily. Then comes a code review. So code review, like in terms of security or the performance or the style fixing, that UI perspective, everything, all those skins can be done now. And CI/CD agents, I mean, like in continuous looping, continuous integration. If you take when something fails, it will take at least 1 or 2 days for the developer or a concerned person to fix it. But the automation fixing is also possible when we are using this AI implemented tools. Then document creation, as we talked before, it's been useful. When it comes to engineering perspective, as I said, in CAD tools, PCB designs are being useful, and also in the BOM analysis. I mean, like if some of you are the PED engineers, people, they will know. And the DFM, the material availability, manufacturability rules, all are these things are possible when it has been AI has been integrated. So moving to the Gen AI, how it works, as I said, a large AI model is being processed. I mean, like a training data set is being processed, and the learning patterns are being they learn the statistical relationships of the structures and the data, and from that they generate. So how they generate, so it is not like just like that they generate. We have to prompt. So I have to give an appropriate prompt. Based on that prompt, they generate a response. So we will see like how these prompt playing a major role in the upcoming slides. So now I think you would have gotten a high-level overview, like what is Gen AI and how it is being used in the different things, models like for a text to speech, audio, video, and all other things, and what are the different things available in the market currently, and how it is being useful in the industries. So now we saw the applications of the different models, how they are being used. But when it comes to implementation part, so first prompt engineering is not just like, okay, actually it is like what we are typing in the, for example, we will take a ChatGPT for our easy case as we are using in a daily life, or a co-pilot or anything we'll just take. So if I just type some instruction, that is nothing but a prompt. So if I type what is the capital of France, it will just give an exact answer. What is the capital of India? It will give me the exact answer. But if I ask like some other questions, can you say me a recipe? It might send a cooking recipe, or it might send a different recipe of any other things. So all these things are being decided. The answer or the output what we got, it majorly depends upon the prompt. That is where the prompt engineering plays an important role. So what is a prompt engineering? So it is like a practice of craft, I would say, like a crafting an effective input, that is input in the sense it is a prompting to guide the generative AI models to produce our desired output. When we type itself, sometimes we will know, or we expect like my output should be in this specific format, or you will have some view like it should produce in this format, and this is so if that is not coming, then you will optimize your prompt, or change your prompt, and based on it you will just give it. So these all is nothing but a prompt engineering. The art of learning is a prompt engineering, how we have to give, how effective we can give, and how structure, in what structure, in what phrases, and instead we have to give to to make sure that we get the exact answer how we need it. So these input can ranges from the simple question to the complex instructions, and say to complex instructions. So as I said before, why this is very much important. What in our day-to-day life we are doing, we are just typing some text in ChatGPT, and we are getting an answer. Is it all the in industry also they are being used for? No, it is one of the way. Yes, we are also checking many of the GPT tools or the Copilot and other stuffs. We are also using it, but in the real time, or in the for the practical implementation, how we do, we, as I said, for example, if we have a tool like a MATLAB, inside that we are trying to implement the GPT. Inside it, we are trying to implement the GPTs for that such that the GPT is specific to that tool. So like that, we are making the inbuilt one. And similarly, if you take industries have a specific code which are like more are like code protected for various reasons, for the security reasons, they have the authentication and other things. So for all those things, we are they are not just blindly using the ChatGPT. They have a I think before topic you have covered the different security reasons and other stuff. So we create a separate model for the our GPT for the specific thing, and that interacts with the main GPT, and based on that our model is designed specific to our means to specific to our domain, or specific to our set of documents which we have. Based on that documents that GPT replies. So these are all important. So when I want to interact with the chat GPT, it's not like we always go and type it. Sometimes the input is given in form of a Python program. So in the program we need it is normal the Python program that we can write it, but inside the program also we need to write as a the prompt has to be given inside the program. For example, if I already have some document, for example a requirement document, I have a product design requirement document, I'm having it. So product design requirement document, the template might be the same, the introduction might be the same, or it might differ. And using AI, I mean not the general AI, the inbuilt AI, we are trying to update the document. So for that, how we can do it? I will already feed the inputs. What are the requirements we have, like the high level requirement, and what are the system requirement, product requirement, all those things is that we will feed it, and we'll have some. We will the programs will have a definite prompts, like can you generate prompt? Consider you are you are like a document generator. Can you create me a intro? For example, I'm saying I'll just write a prompt. Can you create me an intro about this document, so and so document? So it will give me the introduction part. And similarly, can you create a tabulation of what is a requirement and what are the things needed? So it will create a tabular form. Or can you create me a some XY format? It will create the XY format. So all these things are being done mainly by using the prompt. So when I say prompting, if you take a normal chat GPT, we'll just type. If you're not okay, we will retype. If you're not okay, again we will retype. So this is something, a continuous process which we are doing. But when we are writing some program, that too it is a standard program that we are writing to check multiple documents or generate a multiple documents which are like in a same structure or a different structure, based on the training data. It needs to understand, it needs to write. It will not, I'm sure it is not the 100% like it can replace a human, but at least it should give an actual or a realistic content what we have fed into the into the GPT. So based on that, it needs to generate the data. So in such a way, how I can ensure that the document is right? When I'm sure like my prompting is right, based on that, my documentation will be right. The document automation of the documentation will be right. So this is a plays a major role where prompting comes. And these we are facing various challenges in the industries when we are trying to implement it. So we will discuss about it. What are the challenges we are facing? I just want to say this example because I want to understand like what is the important of prompting and why you need to study this. And okay, so we'll go to the next slide. So need for a clear prompt. So as I said, so if I give some XY prompt, it will obviously generate an output. But whether it is a right output, how I will know? So I need to provide an exact or a clear prompt. So why it matters? Generative AI does not think like a human. It responds based on the pattern of the training data. So that's why your phrase or the structure or the instruction, the model can dramatically change the result. Example, I write about, I just write a prompt like write about AI. So it will generate it will give me an output of a generic test. Whereas when I say write a 200 words, a blog post explaining how AI is transforming education in a simple style, if I give something like this, it will clearly my output will not be generic as before. It will be more focused, clear, and also it will give the actual 200 word format. It will not be an exact 200, but approximately it will be give a 200 word format, and also it will be focused like what I'm actually looking on, how AI is transforming in education. So those data can be got clearly only by the way I prompt it. The next thing is AI does not read our mind, as you all know. So it only respond to the word what we give. So we need to very clearly prompt it so that it understands it. What makes the difference between the generic and the random answer, or the high quality tailored answers are like matters mainly because of this prompt. A good prompt always saves the time, improves the efficiency, and also help us to get the best out of the AI things. So when what there are some limitations here. If you see the last point, it reduces the bias and harmful response. Yeah, it has a bias and harmful response. For example, if I go to Gemini and just uh, type a generate image of a working professional, or or a or a factory setup or something like that, if I just type, it is generating my image where most of them are men. So how it why there is no female? There was a question. It is not like a only I have found. It has already been detected. So why there was no female? So actually AI has bias based on the information it has been trained. It is thinking like in the most of the in the factories there will be mostly men's and very few women. So I think that's how it has been trained based on that. So if I have to give specific generate uh, image such as a woman is working in a factory, then it generates those kind of image. So the what we train is also important, and also if unchecked, like a model can repeat or even amplify the harmful content. Since AI learns from the massive human generated data, it can bias and also create a harmful content. To reduce this, what we need to do as a developer, or use techniques like cleaning the data, training data, fine tuning with the human feedback, also adding filtering to catch unsafe response. This makes AI more fair, or I would say like reliable, and increase the productivity, also the control, and also it will be very safe. It will be very safe for a everyday life. So these are the things you need to remember before relying fully on the bot which we make. Then comes to the core elements of the prompts. So I was saying like we need to make a clear prompt. What the clear prompt means? We have a definite structure which is being defined. I'm not saying you need to stick into this particular structure. There are different types of prompts. We will come to know that. But before that, the main core elements, we will just walk through it. So when we take the main core elements, first comes the instruction. So in the instruction places, it helps to summarize the cause. Um, for example, summarize the text. If I say like summarize the climate change, it will just give me, if I give the prompt like summarize the climate change, it will give me the content of the climate change, or it will just summarize why the climate change is occurring, so and so. If for the context thing, like if I give like for a high school student, so based on the high school student, or like a school student, can you just explain me? So it will just explain based on the background and accuracy, based on the input we are giving, as per the, so the high school student will audience will understand. Based on that, it will generate me a particular response. Then the input data. So input data is nothing but a text or a questions. For example, like use the following article. I give us some example to it, like use this following article. So based on that input, it will generate some points. And format and style also, you can say like write in bullet points, or write in some language like .csv format, or XML format, or like a in a table format or a simple language, right? In a simple language, so it is easy to understand. Those input can be given. Next comes the constraints. Keep it under 150 words. Before we said, like, keep it under 200 words means it will almost stick or in and around of the 200 words. Such kind of things. So these are the core elements of the prompting. Next comes prompt priming, which is nothing but, so now I said, like, we prompt generally has these types of prompt needs instruction, context, input and output, and the output indicator, especially when you are writing prompts in the code. I mean, like in automation code, if especially when you're writing, in some of the cases you need to follow these things specifically. Then when it comes to the prompt priming, for example, you need to type a role or a persona, like consider I am as a teacher, deliver so and so lecture notes, or consider I am as a doctor, so prescribe me so and so things, or advise what I need to give for the particular advise what I need to say for the particular report. So you need to tell AI, like, in a friendly way, like yeah, like I'm a friendly max tutor, explain these steps, how I need to explain these steps. So you need to personify the role, you need to specify it to get a better tone or better version of explanation, the I mean the output, what how you want to expect it. Then when it comes to context, you need to give the background or the solution, like a background or the situation, so that AI knows what is going on. For example, as I said, the role you are saying, you need to say the student struggles with a student struggles with the fraction, for example, but knows multiplications well. So it will help to prevent, it will help to say, like, how the fraction can be solved in a step by step manner. So but knows the multiplication, so it will not it will based on the multiplication way, it will help to solve, like how the fraction can be solved. So these contexts are, even it is a minimal context, these things you can just feed it, so that the prompt is made effectively. Then comes the constraints. Define your limits. For example, you might need a 200 pages essay, or you might need 150 words one day. So, or you might need a complex terms or a simple terms, or you need a plaque free plaque free test generation. So all these constraints you need to say to an AI, so that it will generate it, and keep the output so what it helps is, it helps to keep the output focused and also more useful, uh, useful way in what we want. Then comes examples. You can also provide examples in the prompt. For example, like input, like a 1 plus 2 equal to 3. Give it in a simple form like this. Explain me the fraction in the simple form like this. So it will generate the output accordingly. And there are different models or different techniques of prompting. I will cover, I think we'll cover in the next slide. Like a few short prompting are there. So where examples will be given, and based on that, we can get the approximate output. Then when we take the output format, it returns a result as a, you can say, like, return me the, or give me the output in the form of a table, give me the output in the form of a bullet, or a step-by-step explanation, ensures that clarity and there is a consistency, especially in the structured task. So all these things you can mention in your prompting. So these are called as a prompt priming, you say. Then comes the prompting techniques. So what are the prompting techniques? You'll see there are zero shot prompting. Zero shot prompting is nothing but you give no example. I said before, right? What is the capital of India? So in such a case, that is nothing but a zero shot prompting. You're just asking a direct question, or you're just putting some phrase, or putting some words, and you're expecting an answer. So single line answer. That is nothing but a zero shot prompting. One shot prompting, for example, you will give a single example. For example, you can say, like, I give me a place to visit in Tiruchi. I like to go to temples. So it will give the list of temples. I like to go to a temple is nothing but examples. So you are giving some example. Based on that example, it will just generate prompt. So that is nothing but a one-shot prompting. And few shot prompting is like, similarly, you can give a multiple examples. You can say like, I like to visit temples. I also like to visit the historical places and natural. I like to see the nature. I like to enjoy nature. So in such a way, if you give according to that, it will give the reply like so you can visit so and so places which deals with these are the historical places, and these are the temples, these are the nature friendly places. So these things will be defined. Then comes the chain of thoughts. So when it comes to chain of thought, as I said before, so for example, if you want to understand the max problem, that same example which we took before, it can help to AI. Using the AI, we can if you make a proper prompt, like a chain of thought based prompt, it will help to show the output in a step-by-step format. Each and every logic and also the way to solve it can be seen in a step-by-step format. Based on that, you can get the answer. So it will be easy to understand also. It is not only for maths. We can use it in our own algorithm, or like we are when we are implementing something, we can make the chain of thought format, and we can break the complex task into a small task, and ask help the AI to solve it, or give the solution how to implement these simple tasks. So all those things can be done. Then comes the self consistency prompting. For example, if you are making a specific bot, I said, right, for a tool, if you are making a specific bot like a sample multiple COT path, or a pick or a some specific purpose, if you are building so for a harder reason where your single path may error. So for example, like a generate a step-by-step solution, and provide a consistent final answer. So for example, if you are generate or if you are using some specific tool, inside the tool, if you are implementing it, implementing this GPT or a model, any model. So what you need to do is, to log in it, you need to follow this particular procedure. Even though if you ask like the way to log in how many way, in different ways, or like in different types of prompts, it will always generate a consistent answer. So that is nothing but a self-consistent prompting. Then comes the role play prompting, where it sets a persona or an expertise, like as we saw before, like a domain tone, you need to say like, I'm a senior data engineer, uh, propose me a scalable ETL design in bullets, or in an Excel format. So it will provide you a scalable ETL format. So you need to say the AI like what is your expertise, or what role you play, and what answer, based on your role, what answer you are expecting. So all these things can be done there. Then another type is a RAG, that is an retrieval argument generation. I hope many will know this. So here, with the grounded external data, most of the models which we are generating are actually like in companies are like they are using the RAG model, where we already have a set of documents. It might be a manuals, it might be data sheets, or it might be a different coding sheets or other stuff. So all these are being fed, and based on that, and based on the attached PDF and URLs, they just learn it and generate the output. So from there we can just say, answer me in 5 bullet citation, can you explain this part of code, or what is what this particular X and Y is it means. So instead of creating a generative content, as we are training in the RAG based model, it will based on the input fed, based on that it will give you the answers. So that is one main type where the prompting plays a role. By you can also in the prompting itself, you can say like, use this specific PDF file, use a specific version, use a specific URL. From there you generate me summary or a text or an image. These things can be done. Then comes a yeah. multi-turn prompting. So in multi-turn prompting, it refines through the dialogue. For example, like conversational refinement, as I said before, draft me a 200 words paragraph, or shorten to 120 words in a friendly tone, or add a call to an action. Like these, you can make a prompt so that it will based on our dialogue, it will refine through based on our inputs, it will refine it, and based on it, it will give the output. I hope you all are in. Okay. So I hope you understood about the prompting techniques.
Yes, ma'am.
Yeah. Then comes the industrial applications. So 1 second. Before going to the industrial application, it is not like one type of prompt only we need to use. We can combine the methods like a role play with a few shot with a COT. We can combine it, and also there is always a specific format like a constraints for using COT and the self consistency. So based on these, based on our application, we can design the prompt and implement it. Uh, then comes the industrial application. So as I think some of the things I have already referred before. So in automation, technical documentation, it is mainly useful like a manual creation, um, design reports. These are being useful. Test case and code generations, and so not only test case development, code generations in embedded systems, also in CAD automation as we discussed before, and also the PCB simulations, knowledge extractions like passing the standard company policies, etc. Then digital twin simulation, so they have used the RAG, the real-time data one. And in software domain, if you see like a chatbot, like a virtual assistant, which we all know, and also the generation refactoring of code, QA testings, they are being used. I think most of the things we discussed things before. So when it comes to the challenges, I said we are facing lot of challenges. So like the main challenges are like trained on a past data. So already we are feeding some of the input, like these are the documents you need to refer. So it refers to the past data. Sometimes that document might be outdated. I'm not only saying the general GPT, like chat GPT and other things. Some things are like if we build like our own GPT, if we are building into our tool, sometimes that particular document, it might be like it might be upgraded, but the GPT might not know. So all these things like out of date knowledge, out of knowledge, I mean like it is getting out of data. So another thing is the hallucination, like it can generate a confident but a false and unreliable information. So, for example, if I ask some byte number of what is the real time thing, whatever we are facing, I'll just say. So I am just prompting like there is one data sheet. I am just prompting like, can you say me the what byte number 4 of some object refers to? It is giving me a false answer constantly. Even though if I ask multiple times in different ways, it is giving me a constant answer. So why it is generating a false answer? If you see, like when it comes to the text reading or text reading or the image reading and all, it is working fine. But when it comes to a table, reading of a table format, it is not taking the right data. So there we have the challenges reading the table from the document. It is failing, and so it is giving us a false data. It is thinking it is all right, but it is giving a false data. So how we have to improve it, how we are working on it, like should we convert the table format or the chat, we should how we have to make a prompt, like if something is in table, should it convert into an JSON format or some XY format, and from there should we extract the data so that we will get the correct data. So these are some challenges which we are facing. Also the sensitivity, if we give some small word change, it sometimes it makes a big difference. Like if I give a small Indian or a big Indian, give me in the different format, if I say, sometimes it just fetches a direct things which is present in the document. Then the contacts and windows limit, it can only remember like a fixed amount of text, and struggles with the very large documents sometimes. So these are the challenges which we faced when we started implementing it. Some of the things we have tried to overcome, but for some of the things like table reading and other things, we are still having some major issues in data. And the data privacy and IP risk, even though we say is a confidentiality concerns, and other things, the data privacy and IP concerns are still there in industries, and industries are continuously working onto it. And many companies have deployed a separate team to just check, because of the AI, they have just deployed a separate team to check on the data privacy, IP concerns, and other stuffs. So these are the main challenges we are facing in the industrial point. So I think you all now know like what is AI and what tone we have to prompt it, what is the format, style, the level and detailed response, and all these things you will come to know. And the how to okay, before going to some examples, else how to overcome the challenges, if you I said some of the challenges we are saying, right? So how to overcome the challenges, for example, the outdated content, if you're to avoid the outdated content, nowadays we are giving in the prompt itself we are saying refer so and so document. So if that document is not there, it will just give us this version is not supported, or this version is not applicable, like that. Then hallucination, I said, like building a false information. So we added a verification layer where there is a human in hill, that is human in loop review. It will cross check with the trusted source. For a specific cases, it will cross check with the trusted source. Then comes a prompt sensitivity handling. So to handle the prompt sensitivity, apply prompt engineering is the best practice. Like a clear role. Yeah.
ఒక 2 days తర్వాత వాడతావు కదా.
Sorry. Hello.
Yes, ma'am. You please proceed. There are some interrupt.
Okay. So these were some of the mitigations which we had, and how we overcome the mitigations. So we will just go into some of the examples which we have. First I will show the theoretical point of view, then implementation of the code we will just walk through it. So where should I go on my next vacation? So for instead of giving this, it will just give you one vague answer. So as I said, I want to to go a trip, with whom I'm traveling, which location, what I like to see, what is my budget. If you give all this information, it will give you the correct content. And for example, another example is like write a LinkedIn post about the productivity. It will just give a general productivity. But if you are priming write a LinkedIn post about the productivity for a young entrepreneur, keep it motivational, write it 150 words. So if you give more precise content, then it will give you the actual result. So how the priming should be like a feed contest, an example, and the rules before you request. All these things should be fed to it. So I think most of the use cases we have defined, we have already discussed. As we are in short of time, we'll just walk through this. If we have time, we will come to the use cases later. So for example, so this is one of the implementation, which a small implementation, like where we will add the prompt to the code itself and make make and we will check the output. For example, we will just concentrate on the prompt and just say like so here we have used Gen AI, where the model is Gemini, we have been used. So you consider like you are a dog. That is we talked about role or persona. Like it is not only about the profession or anything. You can just type your random data like you are a dog. Your name is Max. So based on it, good morning, how are you? So how the dog responds? Wolf. It said how the ChatGPT gives a response. It gives a response in this way: wag a tail, and it responds. So next, if you we talked about the structure of prompt. So like act like a, so we are giving a role like act like a chef with the many years of experience in the cooking factory. Based on it, so this will be a system role. Based on it, you need to give your prompt. So I need to do so and so things. What are the ingredients I'm using, and format everything as a HTML5. So as I said before, you can give these kind of things, a format, form the way you want your output. All these things can be given here. So based on that, the response will be generated. Like for example, if you when I just run this program, it will give you the HTML version of an output. And here if you see, like I have given the system role as an we can and we have given some system role, and I have asked I have just mentioned some prompt, and I have asked a JSON format. So if you see, it is generating an output in a JSON format. Then when it comes to an okay, then we can also, like now we said, like we saw like different personas or the different roles we can given, and what are the prompts, or how we can give the prompts, like what is the need, what is the example, all those things we can give, or the format also we can give, and based on it we can get the output. If at all you want to make a specific model of yourself, then you need to store the history. So based on the history, for example, if you take the GPT itself, we will type it like what is the weather today, for the first question consider, and second question we are like we are typing it like uh, will it be raining or anything. So or what is if you just type something like a consecutive prompt, it will just check first, it will first what it does is it does just check the previous history. Based on the history, sometimes even though your question is like are not it is very generic, you have not actually had made a proper prompt, it will, based on the history, it will just reply you back. So in such cases you can just store the history, and based on it you can give the you can generate the output. For example, how it actually works is like it stores the chat history in the memory. Then we are saving it to a file. Once it is saved into a file, loads it automatically next time, and supports a loop for a live chatting. So that is how this code helps us. Then when it comes to okay, for example, here I think we have an example. What is the distance to sun in kilometers? It has given the answer. So then what we are asking, what about Mars? So actually what we are inferring is what is the distance to the Mars in kilometers. So even though we just asked the generic prompt, it is replying it. So how it is replying it, when we are writing our own GPTs, like we can use we can save the history, and we can use that history in the retrieve to looping format, and then we can generate the output. So this is a other important thing you need to remember. And the next thing is like okay, I think this also the same part. Okay, we were talking about the audio things. I think you already know to generate an image. So using Gemini, I think you would have tried. So if you are trying to work with the audio things, so for example, here I have given the URL. So fetch and for the following MP3. We will just download it. From there, I want to generate a what I want to do is like if I just print a response, it will down. It will just get the audio and convert the audio file into a text file, and then it will give us the output. For example, when I just run this, if you see based on the print response or text, the response is nothing but an audio file, and based on your prompt, the prompt what I have given is create a transcript of an audio file. So based on the transcript, it is just giving me the from the audio file, this transcript is being fetched out. So this is how the audio sampling is being used. From that, actually this is just a simple case. From here again, you can this input you can give to some model and make some application to do work. So all these things are being possible. So these are the main things. So and also it also if you just get the full data, right, it will just lay like in what time what was spoke, if the what audio in the audio, like it gives a detailed description, like a transcription, it gives a detailed description of all these things. So these are the main things in the what we discussed before. And I think the same thing, this Tesla, the self-driving uses a multimodal prompts like images, cameras, and the instructions and rules. Even in the small like even in some models, the audios are being used to get the data. Means like if some audio is fed, based on it, the system it is making the system to respond, the automating the system to respond based on the particular audio. So all these things are being working in they are working on how it can be accurately done, and other things using the GPT, not just the voice over things, using the GPTs. And sorry, I think other things. And this prompt engineering, I said, right, there is a large number of plans that has been created in the LinkedIn, or if you just search for the need of a prompt engineering, people, there is a large number of people need they have. So it is not just we think like a prompt engineering is just a simple text writing or those things, but it is at the background. If you understand like the real context and the way to write it, the actual concern, how to get an accurate input, because these are the things the industrial people need to know. Like they nowadays, like they know to create a bot, but how to make the bot effectively useful for all the customers, all those things can be verified only with the help of an effective prompt engineering person. So there are a large number of job opportunities also here. Okay, and the future of prompting, I think AI agents you already saw. So it will be like instead of manually prompting, AI agents helps in self-support prompting and raising a multiple AI models like a text. Nowadays, it is not just about text. So combination of a text, voice, image, all these things they are working on. So I think I crossed the time, but this is the content I had to share with you people. You have any questions? And thank you for your patience. I think it's time for you people.
Yes, ma'am. Any questions from the participants? You can raise your hands. Is there any questions? I think there are 4 people raise their hands. Deepika? Yeah, you can unmute and you can speak, ma. Meanwhile, I'll share you the feedback form QR code. I think you can see the screen, right? Kindly complete your feedback as well as attendance form by scanning this QR code. Yes, those who have question can raise. Yeah, Jitendra, do you have any question? Now I have shared the feedback form as well as the attendance sheet QR code. You can scan it and give your feedback as well as the attendance. Yes, Dr. Devi.
Well, we can't see the QR code.
No,
There
I
is
have
another
shared the screen.
Yeah,
Just
that's
I've
the
shared.
thing. Teams window is above the QR code. The QR code is not completely visible.
Okay.
Move the Teams screen. Now this is visible.
Now is it?
Yeah,
Can you
it's
able to see
visible
the
now.
screen? Yes, please.
Yeah, it's visible.
Yeah, complete. I will open it for 2 minutes. And meanwhile, if there is any questions, you can post your questions to ma'am. Vaishali ma'am is waiting for your questions. She will answer you.
Yeah, excuse me, ma'am. Good evening. Ma'am, QR code is not visible on my end. For both the sections, I am not able to fill the feedback.
No, actually, now I have shared my screen
Actually, it's
on
not.
Teams.
Yeah, I am looking for it, but I am not able to see that.
Is it the situation for others too?
Actually, I'm
Otherwise,
able to see.
we will share the QR code in WhatsApp group also. There also you can read
Yeah,
your
ma'am.
attendance.
Yeah, please share it in WhatsApp group.
Yes, I will do that.
Madam,
So if you have any questions, yes.
Ma'am, share both of the
Actually,
session
please show
link,
the
ma'am.
QR code,
Share
madam.
link, share feedback link and test link, ma'am. We are not
Hello,
able
madam,
to
it is
scan
visible.
QR code.
QR code is
Please,
visible.
please, one
Please
at a
show, madam.
time. No, actually, I have already shared. Okay, so your point is we will be sharing you the attendance form and feedback form in the WhatsApp group. Okay, right. If you have any questions, please complete it as of now. Meanwhile, I'll post this feedback form as well as the attendance form in the WhatsApp group. Is that fine?
Yes, ma'am, we need link, not QR code. We need link, test link and
Link
feedback
is
form
also
link.
there. This Google form link is also there. Yeah, one sec. I will just.
Madam Kokila madam has raised her hand for the question
Yeah,
to the
Kokila, do you
have a
resource
question
person.
to Vaishali ma'am.
Yes.
Yeah.
Could I ask it now?
Yes, yes.
Yes, please.
Yeah, ma'am. Ma'am, I want to know something about prompt tuning because future research is going, I mean, many of the research is happening on the prompt tuning, right? Could you speak
Yes.
something on that and what could be the research gap we could identify in that?
Okay. In prompt tuning, what are the challenge? Okay, there are many challenges which we are facing. In to overcome those challenges, mainly we are going for this prompt tuning process. Like you already know, the prompt tuning is means like a process of refining your prompt. So actually it is not like a queue. You mostly we are how we are writing the code in the code, as you have seen, like we have shared a code, right? So there we are writing a code by ourselves. But if there are some things like some bot which can make it a proper prompt, that an AI itself is understanding it. Actually, we are also working towards it. So already we have an AI. So when there is an AI itself generating some accurate prompt, that we can directly copy paste into the prompt, into the model, AI model, and based on the interruption and based on the accuracy, we can extract the particular prompt. So it will be very useful as far as the current things we are facing, current major major, I would say, like we are lacking to make the current prompts. That is why we are hiring a lot of prompt engineering people. So instead of hiring the people again, if the bot could make it, and how to fine tune it, all those things, if they are able to say, it will be very helpful. And also, like I already said, there are many hallucination we are having it, and also the accuracy point, we have the issue, and the control the format, we are not able to stick to a specific format, like stick to a JSON or a table or a paragraph. We are not able to fix it. All those things, if I give some specific input for those, I mean, like for example, we'll just take a simple example, like a PDF I'm giving. So it needs to, according as per the PDF, it should help us to generate the prompt so that can be used in our bot. So these things, if you are able to make a research, or if you are able to summarize it, automate it, it will be very useful. Did I answer your question?
Yeah, ma'am. Thank you. Thank you.
Yeah.
Ma'am. Any other questions?